Okay. Uh, Very good morning to one and all uh, present here. I welcome you all to the third day of the International Conference of the RUTAG, Rural Technology Development and Delivery. Today it's 6th March 2022. Today we take this opportunity to start to think about Gram Swaraj through full of energy or urja with the talk from Professor PMV Subbarao from IIT Delhi. Then we will also see uh, 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 on rural education from INIAS by Professor Chandrasekhar Sharma. Then we will go into the importance of energy and interventions in rural areas with the first session will be chaired by Professor Sudipto Mukhopadhyay and Professor Prasanjit Tribhuvan from IIT Jodhpur. Here we will see four different presentations. And then finally, we will go towards the summary of each of the days of the conference. So let me first of all take this opportunity to invite Professor PMV Subbarao and introduce him first. Professor PMV Subbarao is the head of the Center for Rural Development and Technology, CRDT at IIT Delhi. He had been the Ray W. Herrick Chair, Professor of Mechanical Engineering Department at IIT Delhi. He is an expert in thermal engineering and has a doctorate from IIT Kanpur. He has published several journals and books. Further, his major projects have been in the area of microhydraulics, where he worked on microturbine turbopumps and canal-based irrigation systems. He also went into energy with the help of heat transfer enhancement of compact heat exchangers using delta wings. So he also works greatly into IC engines as well as ejector-based recovery systems. With he has performed several innovative activities through various aspects of the government, including ROTAG. I welcome you, sir, for giving away your plenary talk. The podium is all yours. We honor your, thank you.
Thank you, Professor Plapali. May I share my now?
Yes, sir.
Can you see my screen now?
Yes, sir. It is starting to share, sir.
Okay.
It's visible now.
May I start now?
Yes, sir. You can go ahead, sir. Yes.
Okay, thank you. Thank you very much. Um, at the outset, I would like to thank Professor Plapali for giving this opportunity to deliver and share my experience in this international conference on rural technologies. And the word gram urjas for us is like Sanskrit word which says in public way approximately. Past 15 years, we are developing various energy systems which may empower the rural entrepreneurs, village as a whole getting electrified or so. And let me share these things and how we are inspired uh, by the great words of the Mahatma Gandhi. I was working somebody BHL, one of the public sector which contributes a lot in power generation. They started this program, but somehow they couldn't continue, which says that every village should have their energy generation in their hand. Shouldn't look for other person to help them continuously for their basic needs, which again says nearly Sanskrit, Hamari Urja Hamara Saath, Hamare Haath Jagannath. Jagannath is a word in Indian philosophy that who the requirements to you. So you shouldn't depend upon somebody else to provide the basic needs, and you should own everything and develop own thing. If those base vital needs are facilities for satisfying the vital needs are in your hands, you yourself will be the Jagannath and no need to depend. So these words are inspired by father of the nation, the Mahatma Gandhi, who introduced the concept called Gram Swaraj. He wanted that this should be the center of development uh, in independent India. Somehow it didn't happen. He wanted. So whenever I look at this great person, various concepts, the whole world knows him as a follower of Ahimsa. He achieved independence to India using satyagraha, non-violence also. But there are several things he said about the development of society, people. Every his word inspires me as a great social scientist. Study deep and then try to pick. Maybe I'm dressing like him. Maybe I'm not living like him. I try to have some disease as per his thinking. So this is what, just to recapitulate, the fundamental of Gramsci is that every will be its own republic. And he explains clearly, independent of others or neighbors for vital needs. That doesn't mean that isolation and not having a social friendship or so. He means that there are few ideas or few facilities you need to depend on others. That is obviously welcome. But one should be republic for a basic needs, which he wrote in 1942. And again, he adds that each village should be basically self-reliant, making provisions for all the necessity of the life, food, clothing, clean water, sanitation, education, and so on. The Mahatma Gandhi wanted the independent India to develop in this perspective, but at this point of time, we are very far from that, or we are working in a reverse order. That's where India is now planning for Atmanirbhar Bharat or Nirbhar village, bringing back Mahatma's of republic village, republic of its own. So I always thought that though it is not explicitly stated by Mahatma Gandhi in his writing, all of us will agree that are essential. You need to achieve independence in if you depend on us for electricity or other energy, you can't achieve the self-sufficiency in all that. That's where to have the same words, but adding gram urjas for us and develop energy republic villages through analysis, of course. They're far from the full scale field. Nevertheless, I'll try to share some of the efforts. So when I was thinking that how this energy republic is possible, how a single village having small number intellectuals can be independent, how this great social scientist could say this concept is the most sustainable path for development. And I see one of the great uh, hypothesis by uh, environmentalist who said much later. I'll try to explain how Mahatma Gandhi thought that energy republic villages are will every village can be republic, because this moreover gives one of the wonderful theorem of the earth. Earth is such that it will try to create many local resources sufficient for being independent. And this particular theorem was indirectly stated by Morovis in 1992, end of 20th century, created solubles 21st and challenges to 21st century. The flow of energy from source to sink through an integrated system orders the system. A far connection between concept of grams per hour, but I'll try to explain that. In if I consider our system, planets get abundant solar energy, but most of the planets are not using that energy for good reasons, and there are not well distributed local natural resources. Why that is happening? Suppose if I say Saturn or Jupiter or so, there is a sun and the energy is directly, solar energy is directly incident on these, and which increases some kind of heat up or so, which I say leading to entropy generation, nothing. All because of between this planet and the great source, and the intermediate systems are missing. Suppose if I take same thing in the Earth, which is all the planners, all the individuals who are developing a technology to focus on this, unlike other planets, as per the knowledge which we have concerned, between the sun and Earth, there are many intermediate systems. There is atmosphere, there is a hydrosphere, there is sphere. Each intermediate system absorbs the energy and orders itself. What is the meaning of ordering in a philosophical sense? More energy, but with less increase in entropy. Where resource with the minimal entropy, it is available for further use. That's how an atmosphere, because of solar energy, has a organized winds. Now the wind is an organized because of the solar energy, and hence it is an entropy vehicle. Some of the energy is available for us, and you can stop burn to the extent. Similarly, the biosphere. So that's where the Mahatma Gandhi is such a powerful thinker, that the earth is blessed with natural resources and locally. In fact, now what is more important is native resources are more important than the resources. Get the independence, and you can do on your own. Now, if you think about connection between the solar energy, so every village will have a combination of natural energy resources. All are continuously recycled, renewed by the solar energy. So everywhere there could be some combination of native sources, which will can empower the village not to depend on basic energy needs from central supply systems also. Okay, all these learnings uh, cannot happen in a day or so. I'll try to share my experience of empowering the local entrepreneurs in this and village as how it started. This is the first time when I was pulled in social oriented research. First time I could see the benefit of my own research, and few people are able to uh, earn better than what they are doing before. This happened one local scientist called Mr. Mangal Singh, a director of an institute, walked into my office that the location is a river called in Uttar Pradesh, and the river is little far from the basic village, and there are many hundreds of acres of land on the bank of the river which is irrigated or which is cultivated through water from the river, which is at a lower level. People use many pump diesel pump sets and burn lot of diesel because there is no electricity on the banks of river at that time. That time, this particular great rural innovator, with a concern, he developed a turbine which can eliminate the diesel power pump set. Because he used appropriate technology optimization or so, his turbine was costing 6 lakhs, which is very high for any common man or a small village to afford. That's where they came to us. We applied all the principles of mechanical engineering, fluid mechanics, etc. Through a sponsored where Professor um, worked as a project engineer. I'm sure this was his first research exposure to the society, which made him permanently to work for a rural development later through his master's, doctoral work, and even today. So in this process, now we could decrease the cost of this particular turbine almost 1/20th. 6 lakhs happened automatically, 30. So but we are able to local group of people to avoid the diesel dependence. Not only that, the entire design was handed over to him. They locally made it. I think Dr. Anand knows better than me that they could duplicate many by copying. That's what that yes, we could give the independence. Now they may not remember me. I'm happy that they don't remember me, but they can make a turbine better than that. This is the turning point, like any innovator, while developing a product, he should hand over everything to the local users. That will develop the energy republic. Instead, if we develop some technologies which are so high tech that every other month they'll come back to you, they'll depend on you. Though it is a high tech, you are making more dependent on urban or imported technologies, which is against Mahatma's principle of developing republic villages or village which is its own republic. So continuing with this experience, and we independently developed. This is the one which Dr. Anand directly worked as a project engineer. And the second one was more exciting. We could develop power from a canal and electrify research center. Later, I had to travel nearly 1.6 kilometers above the sea level. Electrified one village has 70 houses with the same technology. This is the one where we made that village, which was not having electricity for the basic needs till year 2008 or so. This entire thing was funded by a group of devotees who believe in service. They funded financially and even service. I only spent 5% spent by this particular I can't even say non-governmental organization. It's a group of devotees who believe in Bhakti through service, perhaps. Then another one was another tribal village, Deep Assam. Again, electrified a small tribal village with 48 families also. This all funded by the local defense services also. We only gave the technology and drawings to this particular last one. They managed everything. I had to make only one visit to the site. So learning from this particular one, then I thought, no, maybe I expand myself to serve the people. I visited one of the social service NGO, very powerful NGO. Even today, it's growing well. Dr. Anil Joshi was the founder of this particular NGO. Somebody, in fact, no, the engineer from BHEL pulled me that let us go and meet the organization. We can make this technology popular, use technology popular everywhere. But this is first time I learned something very important for empowering the locals and making them actually understood the independence only after doing this particular project, I suppose. So when I went there and I started describing the technology, etc., the chief of this organization said that no, we don't need your technology at all. The locals are here having some ancient vertical axis wheel, which perhaps not doing well now because of improper transfer of knowledge over the centuries. This particular wheel, Panchaki, is as old as 400 people say for available in these. So then he made me, if at all you want to help us, you should develop a technology and optimize the design for this particular one rather than selling your technology to us, or not selling, just transferring. This is where I understood. Everywhere there are local resources, local skills. Over the time, these skills got deteriorated. If I'm really feel that I can do, I should learn that one, apply the most modern principles, and then give higher talent back to them, not the product. If you give the product to the village, sustainable development methodology. That's what I believe. So we visited several sites, and one particular site we designed, fabricated, got fabricated, participated in that particular one. And we redesigned the entire layout, optimized with a good engineering drawings also. And we redesigned the entire, okay. So in this case, just 1 minute. Electricity. Okay, I'm sorry. I didn't power the net. So in this case, uh, I'll close the video for a better bandwidth. Okay, thank you. Now, uh, in this case, no, the actual resource was having 10 kilowatt energy or power, but they were getting a half a HP or less than one horsepower, all because the wheel was not designed efficiently or scientifically. We redesigned everything, got it fabricated, uh, them. Then with the same expenditure of the wheel as high as 5 to 6 times. That's where Dr. Anil Joshi got convinced that we can help them. Again, actually, he taught me very good lesson. If I'm interested in helping technological, uh, using technological routes, these villages. What did he say? That I don't need a product from you. If you think you can help us, train our people at IIT Delhi. The first time in my experience, maybe history of IIT Delhi, the people with pass or 12th pass, around 25 people. In fact, this was also coordinated by Dr. Anand. I think Dr. Anand, so last work at IIT Delhi was coordinating this workshop. We could train 25 engineers or technicians, sorry. They were here for 10 days, and we try to explain as much as possible without any expectation. But to my surprise, I was proven to be very wrong in their capability that by 2013 they have developed 15,000 entrepreneurs who could develop sufficient power to run their workshops, floor mills, oil expellers, and became an independent entrepreneur. Because of their great, the government of India honored Dr. Anil Joshi in that year with a Padma Shri. Recently, he got a Padma Bhushan for much more technological interventions in the rural area. We only trained and gave some technical, complete comprehensive training to the people. So, of course, till that point, we were not doing any research, single public. I think Dr. Anand presented one paper, the conference in Pakistan. correctly. So learning from that, many young students got inspired. At present, there are two students developing two different hydrokinetic turbine. I am sure one called a 7S, another called a aerodynamic, which don't have. Here, our effort is much more microscopic. We want to have 100 to 200 watt uh, independent energy systems which can empower even an individual with a minimum cost. Now these products are ready. We are testing in the lab, small scale models, and this is more like a doctoral work with all kinds of things. Means we are continuing with the products. Maybe we'll demonstrate soon this. Now, going ahead with this, again as a second case, I was pulled into biomass energy systems again by the uh, students only. There are so many species are not in use which cannot be efficiently, but unfortunately, none of them understand or none of them respect like Mahatma Gandhi. Perhaps, as I was telling, one which are entropy vehicles. If there is a small piece of grass, if this small piece of grass is not there, means that much amount of solar energy would have been heated the earth and created the entropy. So even the smallest is a plant, no, it is an entropy vehicle. It stopped the entropy generation that time, possess some calorific value. It is ready to get generate entropy by helping the humans with energy. So when you don't understand that, everything looks waste. And waste to energy, waste itself is a nonsense, wrong word by the humans. Nothing is a waste. It is our inability that we can't use them for good reasons. And we irresponsible, realize because of problems. All this open flaring of the scraps of paddy is not understanding the nature resources completely. So my next journey started with again the empowering the rural village. Started that particular one. Okay, we could get several packages which will show the biomass density at various places in India, depending on. So all those places where the biomass density is very high, this biomass could be both all kinds of biomass, including the food products also. But there are many byproducts, many uh, social forests, many forest and forest are projects. All those things come under this one. So based on this particular one, we started thinking about to. So you can see this particular one. All of us are aware that if you have any biomass in various form, so we have so many technologies available at them. Thing which village understood and very efficiently was direct combustion and for heating purpose only. That too, over the time there was a loss of skill and a lot of problem about um, their biomass stuff, big working. But this can be changed by having appropriate fuel process technologies. You can produce high quality fuels, biodiesel, biogas, bioethanol, fossil gas or syngas, and this obviously can be used for a clean combustion. But you can replace completely, perhaps completely. Reiterate all the fossils required for running many energy systems within a village. If somebody carefully design the system and develop and train the manpower, every village can become uh, G Republic. Of course, it takes time, requires time and commitment from many people. So again, not to this particular point, our first research again, when we started a biodiesel research, there is no that I wanting, but the biggest problem is all reactors which were available across the globe, 1 ton production, and who can produce in all these natural resources, vegetable oils, will be sent to the urban area. Urban area will process, sell the biodiesel back to the village. So nonsense, making it a intensive big industry. That's where we thought that the trend worked upon. It's so simple to work upon also that got we designed and got them fabricated locally. Capacity 10 liter batch, 20 liter batch, 30 liter batch, so that in a village there could be an entrepreneur. It takes 2 to 3 hours to produce 10 liters of biodiesel if they have vegetable oil. Mostly the Pongamia and Jatropha, depending on the local resource available. Here also, our effort were to produce the local entrepreneurs, empower the village, the energy. So we directly gave to very few vendors. But what I did under this one was train technician under KVAC training program that time. Unfortunately, this bill didn't pick up in India the way it should pick up. Doing very well in many European countries. Maybe it will come back by seeing the current. Let me go into, like, as I said it now, everywhere there is some local species which has a good amount of oil content. Oil has a less use or a no use for um, food applications. Okay, they're not edible, non-edible, and hence they are best suited for energy resources. And all of you know very well that if you process well and produce a biodiesel, any that available can be directly run with this one. You don't interventions in the existing diseases. That is a great. So if I say you modify the engine again, yeah, technical hiccups or so. But in this particular one, another great thing we worked with an entrepreneur who is a powerful entrepreneur in Fazilka. I don't know. He never contacted us with the help of a company, private company. I don't want to name for the sake of legal requirement. He got 1 megawatt capacity biogas and power generation system, 1 megawatt electricity generation from rice paddy straw. So every day to consume enough paddy straw, use enough biogas and directly use in an engine which runs on a biogas and generates 1 megawatt electricity. All of you can imagine how much capital he invested based on the consultancy from that particular company. But unfortunately, there are errors in the design, especially. They overrated everything. He was getting 200 to 300 kilowatts or so. He came to us, especially one of our student who is a faculty, Dr. Ramchandra. He is the one who directly visited and worked out along with our calculations and suggestions. Okay, whatever I am presenting, I want to say that a group of faculty and masters, even undergraduates, who participated in at various levels developing these projects. So I can't take name of everybody, but I'm only presenting of this big group committed to empowering the village with energy. So finally came to us. We made again all the calculus, etc., redesign entire technology for a better process, etc. Now, if you visit now, this tons per produces 30 meter of biogas and generating the we could make it to the back to the thing, which gives confidence that yes, find a solution is flaring of paddies, scrubs, etc. And we developed these technology to a smallest scale also. Won't have kilowatt also. You could see this particular one. This was one of the win-win situation where the local, maybe well-off, invested all the money. He's trying to develop a multiple products out of this: the electricity, organic manure, and powerful organic nutrients of nutrients. And the biggest win-win situation, all of biogas requires a lot of water because it basically starts with the hydraulic hydrolysis, first level of microbial process. So the groundwater used to have lot many scales, etc. Panja thing. The water enters. Okay, very little water is used. All can be recycled. We found a win-win situation. The water after the bio, when we separate the water from the slurry and try to, it was soft water. It was much better than the water. Means all the soft have entered the slurry. Maybe you can recycle the nutrients also. It was one of the greatest situation: electricity, organic manure, organic nutrient treatment. In fact, now he a best way of water treatment and pump for general utility, reviewing through situation. So that's where we thought, like, time we should take a place and try to develop and develop consider possible things also. This is where because we are at a Delhi, we started a small brother near in Uttar Pradesh. Okay, I'm showing you the recent page. This work. This is called Bahadur in Bulandshahr district, Uttar Pradesh. Bulandshahr district, the village. You could see when you visit the village, like a lot of still their uh, energy needs are satisfied. Of course, it is electrified, but you can imagine how dependable is such electricity or so. Though we didn't start any work there, but this gave a lot of information in terms of excess biomass available. What is the capacity based on the conversion we did at a campus? Okay, so we could see this first level thing. This is the and number of households. It's a big village. And the cropping intensity is 157%. Livestock population, production, etc. The major crops are wheat, rice, sugar, maize, pulses, potato, etc. Major residues produced are many. Some are used not completely and comprehensively. There are major trees which are wild trees, huge forest attached to the village and shedding seeds, so many residues, no solution at all. They're mostly, in fact, okay. So that's how we consider factor for potential estimation, agree, okay, and manure. Then both heating values, time of operation, and convert. Everything is more realistic values because we have developed. If you visit Delhi, every biomass was converted into small scale because within IIT thing. We didn't convert the numbers based on approximation. We did an explicit experiment. That's how we could estimate potential available, how much electricity you can generate from these resources. The step thermal and electrical achievable energy potential from surplus biomass. See that how much electricity can, what is the capacity of a power assuming 6 day operation, 12 hours day per hour, more so, or more also. You could imagine that it is all considerable, really possible to have the self-sufficiency. Then we developed an estimate of, based on the current facilities, what is the energy required. You will surprise to see that if we actually implement the amount of energy available with the biomass is much more than the current needs, etc. Of course, it's mostly when we select this biomass species, almost many of the species tried it ideally converted gas or a syngas, biodiesel obviously, or but there were few species which we never tried. Then we came back and with all information, we found that so many weeds are available, but how to get these seeds and see the etc. When we started looking at just outside Delhi, there is a Sanjay Ban social forest. Once upon a time, no, it has a large diversity of biomass bushes. Because of these weeds not cleared in time, more diversity has fallen down. It looks like the response of the humans clear the weeds and use them for energy, so in order to maintain the biodiversity. So that's where we selected several and started doing all kinds of engineering experiments. First time we took them into our thermal science laboratory for the killer view. Here we put the ultimate analysis and developed a equivalent chemical formula to find out biogas potential or any other possible. So that's how we potential calculation. To our surprise, if the cattle manure is taken as a reference, most of these things, have much more 500, 600%, 700% capacity to produce biogas, which means that we are supposed to be more society oriented. Our research should be more focused on the natural resources. Develop, optimize the technologies, then obviously, energy are possible. So that's where let us try. Now you will, if you come to Delhi, I'll see a library of biogas digesters. I'm very confident that you can't see another player. Many species are converted into biogas. One roof, reasonably a field capacity can be depending on the resources. So we are for months, not like one day. Some are running for past 3 to 4 years, and this is where like you create a will where lot of waste, uncared, no technology is available, and put under a threat of insufficient electricity or energy, highly on the other service, imported services. One has back with you imagine like if you see 1 ton of cattle dung produces meter cube. Suppose if I have 1 ton of bubble seeds, I can get a 400 meter cube of biogas. And if I mix both, I get a high amount of gas used in all ways. But not only cooking. Cooking is the very many of you know that we at IIT Delhi, a group developed a technology, using technology given to many industries, where we can enrich and this car tested in the world standard. We only one in the world who run a CNG vehicle on a biomethane more than 1 lakh. Now many international and national companies are coming up with biomethane, which helped in entering the Bureau of Indian Standard for biomethane production and business. So, at present, we are actively involved in a tractor replacing the 80 of the diesel first with the bio. That 20% later we want with the biodiesel. We want to have the ultimate backbone of village, the tractor with the tools. We want to set up the process of setting up a comprehensive lab where the truck is powered by biofuel. All the appliances are run with this one, proving that it is on this. If we do this particular one, no, perhaps we'll achieve some of the reality achieving RAM were just for us. So we developed a methodology, we explain just try to quantify, develop the models, and every species we have done we have one test setup which is producing the biogas. It's not like a theoretical calculation alone. Everything the field size because of money, etc., or requirement. At the end, so our concept of self-sufficiency is don't give your idea to them. Understand what they want and try to develop a better equipment or a better methodology with their own resources, and you give everything, not the product, knowledge, complete knowledge. I'm proud to say that whatever we have given to the village, no, if I go after 5 years, they did far better than what I had given to them. Even Professor Anand will vouch for this. With this, I'll stop my discussion, etc. And coming back to this great persons, like, let us do the research also frugal level. Costly research for frugal technology is again a problem for future India. Why do you need so much money for doing research? If I can't do research with a minimal money, how can I develop the solutions frugal? Okay, so I'll close my discussion with this great bhajan, most favorite bhajan to Mahatma Gandhi. Though there is the actual meaning is much more than what I wrote. But if I think I know something, can't help the needy, perhaps is useless. This I'll close my discussion. It is just narration of what I am doing with many colleagues, students at IIT Delhi, and may or may not achieve that perfect energy, but a few solutions in that direction. Thank you very much, uh, Professor.
Yeah, thank you, Professor Subbarao, for such a diverse and well having a lot of facts which are unknown to us, particularly the calorific value of the weeds. I had the fortune of visiting your lab in summer of 2019 and seen some of this tractor work starting there, probably, if I recollect. So I will like to thank you again on the behalf of RTD 2022. And now we are open for the questions to the audience. If there are any questions, please feel free to unmute yourself and ask or type in the chat box. Any questions? Okay, sir, I have a question. So, because you fairly conveyed the value of biogas, but what I heard is like biogas has this typical problem, particularly in winter climates, in cold climates, the production issues are there, and this removal of slurry is
No,
also a challenge, I guess.
yes, as I said,
So,
no. Uh,
yeah,
you see, you need to work with the diversified resources. You can't give the entire annual energy resource only with the biogas. That is one way. Okay. A part of the year, the energy resources are biogas. That's how no, the nature created diversity for the sake of uninterrupted services. So summer, very good for biogas, etc. In winter, otherwise you can do a kind of more engineering. Some of the biogas can be burned and the hot water can be circulated. We at IIT Delhi, in entire January, we have a small solar heating system. We get even 70 degrees Celsius. water, hot water. Instead of mixing the plain water, we mix the hot water and we'll get same power. We can demonstrate when you get come in a peak winter, how could we achieve the production? Yes, that is possible. You need to support with some kind of heating. Actually, this is at north of Maharashtra for India. The south of Maharashtra, throughout the year, the temperatures are much better than 25 degrees Celsius. You don't have a problem. That's where no, I say only biogas may not be solution. Producing biodiesel, bioethanol, you need to supplement. In fact, no, that is not a complete. Even for the energy, you should have, I suppose. That is
Yes,
my
yes,
suggestion.
I
Thank
think,
you.
I think yeah, there is a good way to deal with the North India when there is a temperature drop in winter. So other thing I would also like to ask, because you mentioned about this biodiesel also as a supplementary thing. So, and you said that we need to avoid the engine modifications. So, but I mean, blending it more than certain percentage will need engine modifications, right? I mean, what do you feel about that?
No,
I mean,
no. We are running actual diesel engine with 100% biodiesel. You need to
okay,
fine tune the timings, injection, etc.
okay,
This percentage mixing because not availability of enough biodiesel. Whoever is doing experiment, no, they couldn't produce enough biodiesel. But they, in order to produce the result, need a large amount of. So if you come even now, I can show an engine which runs with the biogas and only passes it back agricultural setups like 5 kilowatt. I don't know than that as far as research and helping the people is concerned. But it is possible. Little bit of tuning is required also.
okay, thank you. Any questions from the audience? Any other questions? So I just want to ask one more last thing, because you have
Please.
shown some examples of this. I mean, you talked about implementing these water wheels and wind turbines.
Yes, sir. Myself, Gopal Singh.
Okay, okay. Can you
Yeah,
just
please.
let me finish? Probably will hand over to you. So I
Gopal
just
Singh,
want
sir.
to, yeah, please, Mr. Gopal Singh, just can you give me a couple of minutes? I
हिंदी
will.
में बात करिए
हाँ
सुदीप्तु जी,
हम आप
हिंदी में,
हम
हिंदी में,
हम
हिंदी में.
आपको हम आपका क्वेश्चन लेंगे, थोड़ा सा टाइम दे दीजिए.
ओके सर, ओके, ठीक है सर.
हाँ, तो मैं हिंदी में फिर सवाल भी पूछता हूँ सर, कि आप नाउ वी हैव दिस सोलर पैनल फोटोवोल्टाइक राइट कमिंग इन सच ए लार्ज वे. तो अभी व्हाट डू यू फील लाइक इज द पोटेंशियल
Okay.
फ्यूचर ऑफ दिस
Maybe I'm
सोलर
against entire trend. See the thing, empowerment of village is very, very important while giving a resource or a help. It should not happen. At present, we are doing a Indo-European project. I am is the leader. We are visiting a island called Goramora Island, which is popular in the world as a sinking island. Around 7 years back, somebody gave some street lighting solar PV. If I go now, everything stolen, none working, no help for them. See, solar PV looks easy to immediately give electricity. I do agree. But several cases, no, the takeover, no, you imagine after 2 years, do you think locals can maintain spare parts? Possible. So this is where you need to think about like the technology should be such that 90% of the time, no, not come, etc. Even in the urban area, every solar 7 years guarantee. I always
Yes,
fear to the 7 years. I pay becoming servant. I'm losing independence. No? I'm in their
yes.
hands in the name of warranty
I
guarantee.
mean,
I think
all this is
that is
all
not
this
the
is
one which
important.
can make the independence. That's what I think. Of course, I may be offending many people by saying this.
Then all this is imported, I think, means mostly from outside. So we are not getting self-reliant also in this technology for the photo solar panels.
Even urban level,
And
there is no self-sufficiency. We need to buy the single crystalline blocks. Only in India we have is polish. then assembly. But the most important thing, all these companies which are making single crystalline, polycrystalline solids, taking a lion's share of the.
Okay. So, any other questions?
भोपाल सिंह जी
हाँ, आप कुछ कहना चाह रहे थे?
हाँ सर।
हाँ, नमस्ते जी।
हेलो। हाँ नमस्ते सर। सर मैं
बोलिए।
कह रहा था कि जो एक मतलब नई टेक्नोलॉजी आती है वो गांव तक पहुंचने में बहुत टाइम लगता है, तो उसका क्या कारण है? अब देखिए मैं एक एग्जांपल बताता हूँ मैं आपको। आईआईटी रुड़की से पढ़े हुए एक विद्युत मोहन है,
ओके।
पास आउट है आईआईटी रुड़की से।
हाँ जी।
और उन्होंने बहुत अच्छा मतलब बायोचार पे मतलब मशीन बनाई बायोचार बनाने की। उनका नाम उन्होंने चेंज कर दिया टकाचार।
ठीक है।
और उनको दुनिया भर के इनाम मिले, करोड़ों
हम्म।
रुपयों के इनाम मिले हैं।
हम्म।
अब वो न तो उनका कोई कांटेक्ट नंबर है कहीं पे, न और कहीं कुछ जानकारी मिलती है उनके बारे में। और उन्होंने अपने मशीन का पेटेंट भी करा लिया है। तो इसका फायदा किसान को क्यों नहीं मिलता है?
नहीं,
तो जो अच्छी
एक्चुअली।
टेक्नोलॉजी आती है वो बड़ी कंपनियां उसके ऊपर कब्जा कर लेती है।
हाँ
और
जी।
जो मतलब कि बाकी जो फालतू की टेक्नोलॉजी होती है वही जो है वो रिसर्च सेंटरों में चलती रहती है।
हम्म।
तो सर
नहीं।
वो विद्युत मोहन जी का पता लगाइए, कहाँ पे हैं, क्या कर रहे हैं, और उनकी मशीन जो है वो आम जनता के लिए अवेलेबल कराइए, जिससे कि किसान जो है बायोचार बना सके और अपने जो है जमीन को बचा सके। तो बायोचार एक बहुत ही बड़ी क्रांतिकारी चीज है जो कि किसानों के फील्ड में क्रांति ला सकती है,
मैं
किसान
है
को
ना।
क्लाइमेट चेंज से बचा सकती है।
मैं
हाँ
आनंद जी को
सर।
एक कांटेक्ट दे सकता हूँ। एक रेड्डी साहब है, तेलंगाना के। ये
हाँ
बाय प्रोफेशन एग्रीकल्चरल साइंटिस्ट है। अपना पूरा प्रोफेशन छोड़ के वो साइकिल में घूम के गांव गांव में बायोचार प्रोडक्शन का क्लिन्स बना के उनको एफिशिएंटली करके
हाँ सर।
एंड वहाँ का खेती भी बना रहा है। मैं
हाँ
उनका
सर।
है ना एक बुक भी है, आई थिंक
हाँ
हिंदी में कन्वर्ट किया, चार कल्चर करके, बायोचार कल्चर।
हाँ।
मैं
हाँ वो
आनंद
मैंने
जी को है ना उन।
देखी थी, किंडल पे देखी मैंने सर।
हाँ हाँ। आप श्रीनिवास रेड्डी, आई थिंक उन उसको कांटेक्ट कीजिएगा। ही इज डाउन टू अर्थ। वो किसी से एक पैसा नहीं लिया अभी तक अपना टेक्नोलॉजी
हाँ
देने
सर।
के लिए। हम सबसे वो उम्मीद नहीं कर सकते। कुछ लोग होंगे। अभी है ना, यंगस्टर का आइडल कौन है? बिल गेट्स है।
हाँ सर।
बिलीनियर क्यों बनना चाहिए मुझे? जितना भी हूँ मैं, क्यों बनूं? ऐसा कोई
हाँ
पढ़ाता है? नहीं पढ़ाते हैं ना, अनफॉर्चुनेटली। तो जो है, बट आप रेड्डी साहब से कांटेक्ट कीजिएगा। मैं भी हेल्प करूंगा अगर रेड्डी साहब से कांटेक्ट करवाने के लिए। एंड हम भी
हाँ सर।
कुछ क्लिन्स बना रहा है, बट हम है ना बहुत एज में है। हमें
हाँ सर।
1-2 साल लगेगा, तब है ना हम पूरे हर विलेज में ट्रेनिंग कैसे।
हाँ सर। नहीं
ओके,
सर,
बट
ये जो
अभी
क्लीन उन्होंने विद्युत मोहन जी ने बनाई है वैसी आईआईटी जोधपुर में क्यों नहीं बन सकती है? और
बन
दूसरी
सकती है, बन
जगह
सकती
जो
है।
इंजीनियरिंग कॉलेजेस
क्यों
है
नहीं
वहाँ
बन
क्यों नहीं
सकती?
बन सकती है?
बन सकती है, बट वही, बट हर हर पर्सन का कुछ तो टाइम लिमिट होता है। आनंद जी, आई थिंक यू शुड कांटेक्ट सम ऑफ द केमिस्ट्री प्रोफेसर्स
श्योर
who
सर
understand, and it is possible,
ओके सर
and it can be done much cheaper and local materials. मैं एक
यस
लेक्चर बाद में दे दूंगा में। 2000 साल पहले ना हर गांव में है ना एक बायो होता था।
हाँ सर।
बहुत सारे लोग हवन करते थे लैंड में। ये पूरा
यस
भक्ति
सर।
से जोड़ दिया, बट जो हवन का रेसिड्यू है ना वो पूरा बायोचार था।
हाँ
क्या
सर।
ऐसा स्पीशीज डालते थे? चार नहीं है ना,
हाँ
आप
सर।
भी जानते हो वो पूरा करते हैं, मतलब जो कार्बन वो नेच वही करते थे। बट
हाँ
वो
सर।
पूरा है ना, लोग आस्था बोल के छोड़ दिया, क्या करे? जो साइंस
हाँ
था,
सर।
पावरफुल साइंस था, उसको आस्था या कुछ करके वेस्टर्न बिजनेस इंडिया है ना हमें रोड पे लेके आया।
हाँ सर।
तो ये
तो नहीं
पॉसिबल
सर
है
उसने, सर बायोचार में क्या होता है, एक टॉरिफिकेशन की प्रोसेस होता है। तो बाय टॉरिफिकेशन बेस्ट क्वालिटी का बायोचार बनता है जो कि विद्युत मोहन जी ने बनाया है। अब उन्होंने उस पे पेटेंट भी लेके आ गए हैं, इनाम भी ले लिए हैं करोड़ों रुपयों के, और न वो मार्केट में आ रहा है न और कुछ है उसका फायदा। तो सर आपके आईआईटी के इतने बड़े समूह हैं, संगठन हैं, तो वो फील्ड
मैं
में
वही बोल रहा हूँ ना,
पहुंचाइए।
अब विद्युत
हाँ
मोहन
सर।
रिसेंटली, बट हाँ
हाँ।
है, बट लेट है। ये है ना, हम खेती भी बना रहे हैं, हमने सरसों पूरा किया, तो
हाँ।
इतना सल्फर बढ़ा दिया हमने पत्ते में, स्टेम्स में, बट हम सीड्स है अभी। अ, एक बार हम हमारे कैंपस में फील्ड टेस्ट कर, यहाँ चाहिए मोर एंड मोर, तब है ना परहैप्स आ जाएंगे आपके पास। अभी हमारा बहुत सारे है बायोचार में काम कर रहा है। जब फील्ड ना हम फ्रीली डेमोन्स्ट्रेशन देंगे, बट उसके लिए चाहिए
हाँ सर।
पक्का।
Sir, Bhopal Singh ji has requested your mobile number on the chat.
हाँ सॉरी।
भोपाल सिंह जी हैज रिक्वेस्टेड, इन्होंने रिक्वेस्ट किया है
हाँ
आपका फोन नंबर के लिए, तो
मैं मोबाइल, हम एक और प्रोफेसर भी, प्रियंका कौशल, शी इज आल्सो वर्किंग ऑन द बायोचार एटसेट्रा।
यस यस।
स्टिल एज ए हमने तो शुरू की, दरअसल साहब हम इस लेवल तक नहीं आया कि आपको टेक्नोलॉजी ट्रेनिंग दे, बट एक साल ज़्यादा से ज़्यादा लगेगा आपको फ्रीली अपने आप बनाने का, लाइक जो नाम तो टोरिफिकेशन बोलते हैं, उसके लिए हाईटेक हमेशा जरूरत नहीं है, कुछ चीज़ कॉस्टली भी बन जानबूझ के।
ओके सर, थैंक यू सर। और एनी अदर क्वेश्चंस, कोई और सवाल?
सर आपका नंबर, मोबाइल नंबर थोड़ा।
हाँ हाँ, आनंद जी दे देंगे
डॉक्टर
मोबाइल नंबर, नो प्रॉब्लम।
आनंद, डॉक्टर आनंद आपको
अगर
प्रोवाइड कर
मैं
देंगे।
क्लास में हूँ तो इमीडिएटली बात नहीं कर पाऊंगा, बट जब भी फ्री हो जाऊँ तो मैं भी बात करूंगा, ठीक।
कोई और क्वेश्चन या सवाल किसी audience से? Okay, if there is no other question, then let me thank Professor Subbarao once again. Yes, yes. Yeah. Any questions? Okay. This is not clear. So let me thank Professor Subbarao once again for delivering this wonderful talk and bringing all the facets of self-reliance in energy, मतलब जो ग्राम स्वराज ऊर्जा, ये बहुत ही अच्छा कॉन्सेप्ट है, और हम आशा करते हैं कि यहाँ पे लोगों को इससे एक इंस्पिरेशन मिला है. So I will thank once again and end this session, and we will move to the next session of panel discussion and poster presentations. Thank you, sir, once again for joining.
Thank you very much. Have a good day. All the best. No?
थैंक यू सर।
Yes,
यस सर,
yes, sir.
थैंक यू सर, थैंक यू सर।
Thank you.
So we will start with couple of posters, and then maybe we'll have some discussions. So I request the first poster to be shared. So I call upon the authors of this poster to briefly explain their ideas in 5 minutes, because we have other things also. Anyone present from?
Yes, sir.
Yes, please go ahead.
Good morning, sir. So my name is Rajesh Chandra, and today I'm going to present about the paper on oxygen level measurement in water using IoT devices for efficient aqua farming, along with my friend Monisha. So as we can see, water quality is one of the prime requirements of any living organisms. Manually collecting samples for dissolved oxygen measurement for a given area is actually complex as well as time consuming. So sensor devices are used for this purpose. So sensor devices for dissolved oxygen level measurement, forming clusters of wireless sensor networks are providing solutions for these problems. These features are actually exploited for this research, and enhancements are made for the collection of data from the gateway nodes. Real-time SMS trigger to stakeholders and web-based information flow from the cloud are the unique proposition in this paper. The innovative ideas facilitate in the transportation of data to cloud, and online computational analysis actually coupled with real-time reporting will save the time as well as energy in dissolved oxygen level measurements. And it also aims to prove the information with the accuracy on real time from any part of the world. So our problem statement is that traditional methods involve very expensive laboratory testing and use manual sampling processes. So this requires real-time analytic methods and quick detection of the abnormalities to minimize the contamination. So in manual and conventional method, it is not possible to actually collect the number of samples simultaneously and monitor systems on real-time basis. So this research aims to find a solution for this problem using IoT devices and detect the anomalies in the water quality in the real-time domain. Also, there is a need for analyzing adequate set of samples for determining the accuracy of results, which is more complex in real-time environment given in nature, such as lakes, rivers, ponds, etc. So as actually as Geeta and as Gautami has already presented a detailed survey on the tools and techniques employed in existing smart water quality monitoring systems. And also Prasad M. Pujar et al. Has also proposed a system for water quality monitoring using different sensors for different parameters. So here the sensing is done for only deviation and difference from the normal sets that are actually collected through Wi-Fi network for analysis. Also, N. Vijay Kumar and R. Ramya used Raspberry Pi and IoT modules with Wi-Fi for monitoring water quality and view the data through using cloud. Yes, sir. So in this research work relating to the IoT, basically the following elements, so the elements that I'm going to say are important for the effective apportionment of the correctness of data collected for dissolved oxygen in the water. So dissolved oxygen is an important parameter in accessing the water quality because of its influence on the organisms living within the body of water. The dissolved oxygen DO levels in the water are also dependent upon the atmospheric pressure, temperature, as well as salinity. Microcontrollers and mobile cloud integration using SIM module programming interface for sending the SIM triggers to the stakeholders for reporting the exceptions and management functions is also provided. So the proposed plan is that there is a galvanic cell sensor used which can measure the dissolved oxygen in the range of 0 to 20 milligrams per liter with an accuracy of 2%. So the sensor provides voltage proportional to the dissolved oxygen in the solution. This reference voltage will be the input to the microcontroller board for the conversion of the data. Alternately, OPTOD can be used. So OPTD probe uses a luminescent optical technology that is better suited for the IoT monitoring of the dissolved oxygen. So here we use gateways nodes called as sync nodes. Each sync node sensor a cluster has a connectivity with a number of other sensor nodes that are deployed in a specific area of water where the dissolved oxygen level is to be measured. The communication link between the source nodes and the sync nodes will have to be designed a WAN technology. Depending on the coverage area, we can use the WAN technology for that. The gateway is also responsible for the data analysis and forwarding of the sensing data to the remote sensor. For that, we use UDP packets. And the research outcome is that a big area of ponds or lakes can be covered by using the cluster-based wireless sensor solutions, having dissolved oxygen measurement sensors as edge devices of the IoT network thus formed. Application of the OPTOD clustered wireless sensor network environment for accurate interpretation of the results as well as cloud-based processing of the data, web-based SMS alert mechanism in the real-time domain are also specific research outcome of this project. The objective was actually to design and evaluation of the solution for finding out the dissolved oxygen level detection in the IoT networked system, where both the local computing as well as transmission resources are limited and a mandate to be accomplished with the scope of the future research actually. So these are some of the references that we have taken for the project. S. Geeta and S. Gautami, Internet of Things enabled real-time water quality monitoring systems. Prasad M. Pujar, Harish, Umakant and P. Kulkarni sir, water quality assessment and monitoring for River Mahaprabha.
Yeah. That's
Sir.
not required. Yeah. It's fine. It's fine. It's fine. Wonderful presentation. If anybody has questions from the audience.
Okay, one quick question from my side. So you're proposing the system, right? You have not made it. But
Yes, sir. Yes, sir.
for implementing in rural side, so cost is one aspect. So do you think that this will be economically sustainable?
Sir, pardon, sir. Can you please repeat the questions?
My question is that system you are proposing
Yes, sir.
economically affordable for
Yes, sir. Yes, sir. It is economically affordable, sir, because here we are using sensor technology. So hence it is very economical, sir.
So can you give an idea like what will be cost of your unit? Like per unit, what will be the cost?
Sir, can you please pardon, sir?
So the question is, can you give an idea like tentative price? I request all people who are not speaking to mute. Those who are not addressing, please. We have somebody who's not on mute. Okay, so the question is like, can you tell what will be the unit cost? I mean, for your this device. Hello. Hello. Okay, I think we lost them. Maybe we can switch
Sir?
to the next.
Sir?
Yes.
Am I audible?
Yeah, you're audible.
Sir, sorry, sir. I have muted. The sensor devices actually cost 15,000 rupees, sir. As well as the gateways with the solar panel, along with the solar panel, it will cost around 33,000, sir. So it will be very cost effective, sir. The hardware cost is also very effective.
Okay. Thank you. So maybe we can move to the next poster.
Yes, sir. Thank you, sir.
Yes, sir, we are having another presentation. Our guide is Dr. KKR, sir. Thank you for giving us this opportunity to present the poster. And now the main abstract of this poster is development of IoT uh, using the IoT devices. We will develop the aquapan to increase the livelihood of the organisms which are present in the pond and the proceeds of the aquafarms. The main abstract of this is all attempts at increasing human food supplies inevitably produce environment consequences. So by using some IoT technologies, using by some IoT technologies, we revolutionarily fish farming and other related aquaculture process using some sensor networks, which would be used to measure the pH level of the water and the temperature and other parameters. We can also measure them. So that is why we'll use these IoT technologies to take all the parameters from the water. And the main objective of this project is to develop and deliver the required number of IoT devices that enable the user with IoT-enabled smartphone management system. That means will help the farmers how to monitor and how to manage the how to manage the water level and what is the pH of the water and how the organisms can live and how they can survive. So we'll give all the circumstances, so it will be very helpful for them. So we have taken the literature review from some people. So S Geeta and S Gautami presented a detailed survey on the tools and techniques employed in existing smart water quality monitoring systems, and Mr. Prasad M. Pujar at L Process proposes system for water quality monitoring using different sensors for different parameters, and some other people has already given more detailed survey on this. Example, Nigan Thai Nie et al. Proposed deep learning with short-term and memory models for forecasting water quality indicators. That means it will indicate the water quality with using the system architecture. For example, like for fish and for shrimp, like for those ponds, will monitor. It will monitor the water quality, and we'll use the predicting existing technologies and sensors for predicting these levels. So the setting is for this one is, first the consultant team will examine the places where the pond will be and what is the requirement and what we need to do for keeping these IoT devices, and make the make the water levels and all other parameters and how to analyze them. First, they'll just see the place where the pond is and what are the requirements what they need. Next, the consultant team will conduct in person and tele interviews with nominated team members. That means they'll just ask what is the main reason that they are losing their farm. That means why they are getting lost, and what is the reason that they are not getting proper way of production. So first they'll consult and they'll take the uh, uh, review from the pond farmers, and the consultant team will carry standard sensors and devices that would be used to fetch values of certain parameters of the pond. Next, they'll take the pond reviews. That means what is the water content and how water content pH level and how the water is and what are the measures we need to take to grow the shrimp or fish to produce a higher production. And they will take the raw data, post data collection, and the consultant team will collect all the data and analyze them clearly so that they can give the suggestions to the farmers. Next, what are the materials, methodologies, and designs we used um, in this is the remote pond monitoring system is a combination of sensors and IoT gateway and IoT platform. That means that monitoring system remote will help us to analyze what are the essential things needed for the pond, and the smart pond manager act as main central unit which is perfectly suitable for remote pond monitoring applications. And this permeable membrane allows oxygen from the sample water to diffuse into the sensor where it reduces at the cathode. Next, the IoT platform delivers a comprehensive platform as a service, that is called PaaS, which enables the rapid design, development, deployment, and operation of consumer and enterprise IoT applications. Next, by this setup and all the things, we'll get some results. That is, we can know the oxygen level of the water and how much the pH level is, and how to increase or decrease and what we need to do for that. So we all take the review and we'll get the final result as oxygen concentration increases, partial pressure and the rate of diffusion also increases, and the current to the instrument increases proportionally. So the IoT platform takes the end user customer application dashboard and mobile application access along with all-in-one synchronized functionality for various applications dependent features such as device management, device connectivity, data storage, and data analytics. Next, fish farm management can be automated to be easily and monitored from the location, saving time and money, making application agriculture operations more efficiently, even eco-friendly. We can do this even more eco-friendly. So the conclusion is that for this poster presentation, the conclusion is that the work represents the current business and technology landscape, understands the envisaged end stage, and define a roadmap that would enable the vision and help the technological advances through a well-defined business strategy. That means this is so scalable and accurate and mobile. The final report demonstrates through understanding of existing pond and agriculture system. We just want to take the reviews and all those from the farmers, aqua farmers, and these are the conclusions of this poster presentation. Thank you everyone for giving this opportunity, and our guide Dr. KKR sir, Dr. K. Koteswar sir has given us this to present in this, and thank you everyone. If you have any doubts, you can ask us.
Okay, if there are any questions,
मैडम ये डकवीड की फार्मिंग इंडिया में क्यों नहीं हो रही है? डकवीड,
Excuse me sir, can you speak in English? We are
वुल्फिया ग्लोबोसा. Why in India Wulfia globosa is not grown? That is duckweed.
sir, once again can you repeat?
Madam, Mr. Bhopal Singh is asking that why duckweed is not grown in India, right? So, do you have an answer for that? Yes or
Yes
no?
In
sir,
India,
yes
it
sir.
is the highest market. India, it high demand. But why it is not grown in India?
Yes sir, yes sir, just a minute. My connection is not able to. Duckweeds are actually they are grown in at the temperatures of 28 degrees, sir. So at the temperature around 35 degrees, growth is almostly stopped. So we need more requirement for sufficient sunlight, and almost many areas of India throughout year having high altitudes and with high temperature. So that is why we are not able to grow that duckweed, sir, in India.
No, India is the highest hot country. It is a very hot country.
Yes, sir.
Yeah, but the climate is very suitable for in duckweed.
Actually, it need a optimal growth temperature of around 28 degrees, sir.
Yeah, the temperature is viable for the duckweed, ma'am.
So that is why the growth is almost stopped in all other areas of India.
Climate is completely suitable, ma'am. It is,
Yeah, yeah,
but
yeah.
why we are not growing? Yes, and it is highest protein content. Very, it is the best superfood. And why the farmers? I want the seeds of Wolfia globosa. Where could I able to get?
Yeah, yeah.
I think
Anybody from the audience has the answer?
I am
Or
unaware
we
of
go
this,
for?
sir, so I am not unable to say
Sure,
this,
sure,
sir.
sure. Thank you.
Yeah,
Thank you, Maunisha ji.
yeah,
Thank you
thank you,
very
sir.
much. Yeah, yeah.
Yeah.
so.
We will move on to the next session. Dr. Sudipto, are we going in for the next session now?
Yes, if this plenary speaker has joined, then we should
Yes,
move.
yes. Professor Chandrasekhar Sharma has joined.
Okay.
Yeah.
So we will
So-
move to the next plenary session, and maybe we'll again have some time for discussions or any poster if left.
Yes. So, very good morning again. Today, we are fortunate to have some thoughts on rural education because it's an important aspect of dissemination and skill building, as well as the knowledge gain and other things. Professor Chandrasekhar Sharma is an associate professor at the Department of Chemical Engineering at IIT Hyderabad. He is the chairperson of INIAS, Indian National Young Academy of Sciences. He is also a doctorate in chemical engineering from IIT Kanpur as the earlier speaker. In 2010, he graduated from there. His areas of expertise are carbon-based microelectromechanical systems. He is interested in micro-nano fabrication. He has a lot of interest in energy storage and batteries. He has also in-depth knowledge of sol gel processing aspects from chemistry or chemical engineering. His work is also intertwined into taking forward INIAS into the paths of rural education. When he is handling this position, he has made great roots into the aspects in which the education in the rural areas, rural villages can be profitably brought in as a proposition that it could help future generations. And thank you, Professor Chandrasekhar Sharma, for being here with us today. It's an amazing opportunity to have you here, sir. The podium is all yours. Thank you.
Thank you, Professor Ajay, for very generous introduction. And it's really my pleasure to be part of this third international conference on rural technology development and delivery. Can you see my video is stable? Because it seems there is some instability in my video. I don't know. If that is the case, then
there is some instability in the video.
I don't know what's the problem. So then please excuse me, then I have to stop the video.
Okay, okay, sure.
So thanks a lot for having me here. And it's my real pleasure to talk about some of the activities of Indian National Young Academy of Sciences, especially in the rural education. So let me briefly share the screen. Can you see the slides?
Yes, sir.
Okay, thank you. So I will take some time to introduce Indian National Young Academy of Sciences, which is in short called INIAS, since it's a very young academy, not just only in terms of representing the young scientists, but also its inception was in 2014, late 2014. So we call it as INIAS, and we were established in December 2014 by our parent academy, Indian National Academy of Sciences, INSA. And we are headquartered in Delhi within the INSA premises. And when this was established in 2014, the idea was to have an emphasis on gender diversity, institutional diversity, and I'm glad that even after 7 years, we have not just only maintained, but we have strengthened these values for INIAS. So this is INIAS is only established and recognized Young Science Academy of India. And when we started in 2014, it was started with 20 founding members who were selected by INSA that time as who were all recipients of INSA Young Scientist Medal Awardee. After that, we select our members on annual basis by an open call on a national basis. So the mission of this Young Academy was to engage in interdisciplinary and intergenerational dialogues on scientific issues with the following vision statements: promotion of science education and outreach, which we have done at various levels. I will just give you an idea about what kind of outreach and science education we are pursuing. Were networking amongst the young scientists of India. Of course, as a young academy, we were having a mandate to work and network with the young scientists from all disciplines. Supporting the young scientists in career development and independence, what we have observed that there are a lot of difficulties when the young scientists switch from PhD or postdoc to their independent career. And that is where the academy should be of their help. Building the scientific temperament across the country, which is of course related to the younger generation, especially because when we can educate or when we can motivate our younger students for the science, that will help us in building the scientific temperament. Collaboration with the other young academies worldwide. So not only just within India, we are also collaborating with the young academies worldwide, which this movement of young academies started in sometimes in early 2000. And now there are 95 countries who are having the young academies. So we collaborate with them on a very close basis. So with these vision statements, we moved further, and this is the structure of INEAS. There is a chairperson for 2 years, which is elected by the INEAS members in their annual general body meeting. And in fact, the unique thing about this academy is that the membership is for 5 years. So it has to be, I mean, the overall nature of the academy is that it has to be dynamic. So once you complete your tenure of 5 years membership, then you are no longer part of the academy as a member. You can, of course, contribute to its objective, to its vision by even becoming an alumni. So then currently we are having 102 members, and the tenure of membership is 5 years. And these members are shortlisted and selected not just because of their academic credentials, but also based on their science outreach activities. Because what we have realized that based on only academic credentials, there are several awards. But as an academy, we need someone who is really dedicated and passionate about the science outreach activities as per the mandate of our INEAS. And among these members, we select core committee members, which are basically kind of apex body for day-to-day and policy decision making with the 9 members. And among these 9 members, there is a chairperson. So I just completed my tenure. So I am no longer as a chairperson. I just completed my tenure a couple of weeks ago as a chairperson of INEAS. And currently now we have 48 alumni. So 3 batches are already now into the alumni batch. So if you see the core committee of 2021, which I was heading, and just 2 weeks ago, we have now new core committee, which is headed by Dr. Rajendra Thakur. He is professor in IIT Delhi, and he is currently the chair of INEAS. And what you can see in this core committee is that there is a more than 50% representation of women. And that is where one of the core emphasis of INEAS is to have the women empowerment and having the women in the leadership role. And in fact, the first chairperson of INEAS was a women scientist, Dr. Anindita from Kolkata. So these are some of the activities of INEAS in a very nutshell. I will go through them, and then I will emphasize on the activities in terms of rural education. So we do the lot of science outreach, which includes the remote area lectures and science camps. And these both outreach events, they are targeting towards the school students. And remote area lecture, as name already suggests, that it is basically for the remote areas, including the villages. And science camps are also focused towards the villages, but we do the science camps even in the cities as well. Then there is a training program which is organized by INEAS in terms of workshops, webinars, especially in the last 2 years because of the COVID. And these are targeted for the young scientists, especially the PhD students, postdoc students. In last 2 years, we have extended our activities towards the community service, especially because of the COVID pandemic. And we have made several awareness programs targeting the general society. We also, as a scientific academy, we also do the publications. We have edited special issues of Proceedings of INSA Journal, Resonance, which is a popular science magazine by Indian Academy of Sciences. So we have edited a special issue of Resonance as well. Many of our members, they are part of the white papers or the national task force, which are effective in policy making. We do the liaising with the national academies. For example, INSA, of course, is our parent academy, but other than INSA, NASI, IASC, we have some joint events with them. And also at the international level, we collaborate with the Global Young Academy, which is headquartered in Germany, and then other national young academies, especially among our neighborhood countries. And again, the scientific meetings is a quite regular affair for INEAS in terms of organizing various conferences, symposiums, annual meetings, and the National Frontiers of Science, which is a very unique event, which is supported by Principal Scientific Advisor Office, Government of India. So in terms of science communication and outreach, this slides basically summarizes that, at what level we work in that direction. So science communication at different levels, that is what INEAS does. So if you see in terms of school levels, we organize the workshops, science camps, and remote area lectures. While we go to the college level, we do the scientific seminars, competitions, skill development workshops. And then when we go for little higher like PhD and postdocs, we do organize skill development workshops and various kind of national level competitions. And among the early career researchers, networking, skill development workshops, and of course this Frontiers of Science meeting we do organize for them. And as far as in general society science communication is concerned, we work on different kinds of white papers, which are important for the science policy making. We have done a lot of surveys, especially in the last couple of years, on various issues which are affecting the society. For example, effect of COVID on the PhD students, and the need for the curiosity-driven research, and also the very latest one, the current status of young researchers in India. And we do organize public lectures on very generic topics for the benefit of the society. So some of the key initiatives of INEAS, especially in last few years, that we are organizing this NetForce meeting. We have been given this opportunity by the PSA office. And this is a very unique platform for brainstorming amongst the young scientists. This is a 3 days residential meeting. So we first time did it in 2018, 19. Last 2 years we could not do it. And again, next week we are hosting it again, NetForce 2022. We do promote the Indian science and Indian science journals in various ways, like as I mentioned, special issues of Indian journals. And we also have a very focused lecture series, SIPP, Scientists from India's Past and Present, where we organize these lectures highlighting the contribution of Indian scientists. Scientific awareness in local language, especially when we talk about the rural outreach, it is very important that we come out from our comfort zone and make this awareness, make this outreach in their local language. And that is where we have put more emphasis. And I am quite happy that through our local chapters, we are having various programs in regional languages. We do celebrate National Science Day, Women's Day celebration. In fact, tomorrow on the eve of the Women's Day, we have some event. Technical symposiums, workshop, webinars is quite regular, as I mentioned. Innovative science outreach activities. So when we do the science outreach activities, we always consider some innovative component into it. For example, Sci Art Image Competition, which is an international competition now. And here, basically, we promote that some of the scientific findings are given in terms of an artistic manner so that the message can be communicated to the larger masses. And that is why we call it Sci Art Image Competition. This is currently just finished, and we are going to evaluate the entries for this year. And science outreach for school and college students for rural as well as urban areas. Some of the key achievements in last 7 years of journey of INEAS, which is a very short time, of course, but I think we have made our presence realized at the national level by having the representation in various science academies meetings. We have active scientific collaboration among the INEAS members. We do participate in worldwide meetings of young academies. In fact, INEAS is one of the most active young academy in the world. Strong representation in Global Young Academy and as members, EC members, and also so Global Young Academy is kind of umbrella academy for all these young academies, headquartered in Germany, and many of our members, they are member of GYA, and also some of our members, they are in the executive committee of GYA, and in fact our founding chair Dr. Anindita was co-chair of the GYA last year. We have global engagement on research through various meetings and through various tours. And then apart from all that, I would like to highlight that, several of NEAS members, it's not just only the outreach or contribution to society, but at the same time, we are equally contributing, we are equally excelling in our own scientific fields. And that is reflected here that several of our members are top science awardees like Patnagar Award or Swarn Jayanti Fellowship, etc. And they are editorial board members of international journals. And we have, because it's a young academy now, many of our members are now crossing 40, 45. So they started becoming fellows of senior academies as well. So some of the major initiatives, especially in the COVID-19 pandemic time, because a whole lot of outreach was changed in terms of strategy because of the pandemic, because we could not organize a lot of camps, rural area lectures because of this COVID. So we had to change our strategy in last 2 years. And in fact, this has given us a opportunity to spread the message to a wider community through the digital platform. And I think this is kind of blessings in disguise that we have now learned that how to use the digital platform for the science outreach, science communication. So there are several of these initiatives which we have taken in last 2 years, especially. So some of them I will just go like a sneak peek. So this is Vigyan Setu webinar series on COVID-19, which we started and very early when the pandemic started in May 2020. We started the series with jointly with INSA. And what we have emphasized in this series is that we should be able to communicate the right information, right? Because I mean, there are some memes also that, it was not just only the pandemic, but there was an infodemic. There were a lot of information which was coming from WhatsApp, Facebook, social media, and it was not authentic. And it was very, very confusing for a general public. So we emphasized that we highlight and we promote the authentic information in this webinar series. And you will see that this was very popular. We have more than 23,000 viewers on INEA's YouTube channel in this series of 15 eminent speakers. Many of our members, they have written articles, they have interviewed, they were interviewed on various print and electronic media based on their expertise on the COVID-19 research. Then last year when the COVID vaccination started, then there was a lot of issue initially, a lot of apprehension about the vaccine hesitancy, and INEAS has taken it as a challenge, and we started a vaccine awareness program on a very in a various ways by launching this campaign in April 2021. So we had released a Mythbuster document on the vaccination in general in 11 regional languages, as listed here. Then we have made a mobile app, COVAC News, that was basically giving the information, updating information on the vaccine and different aspects of vaccination. We have also done the competition for the school students and the college students, Pan-India Infographic Vaccine Awareness Contest by VEC. And also we have made several open statements on vaccination. So this was a multi-pronged approach which we have taken for vaccine awareness in the country. In fact, I'm happy to note that this vaccine awareness campaign was taken a note by Honorable Supreme Court of India. Then another awareness series we have made, that is Gyan Tika. So as the name suggests, it was basically the knowledge about the vaccine. So the first Vigyan Setu was more on the COVID-19 aspects, but then last year we have focused on the vaccination aspects. So again, this was the monthly webinar. We have organized 10 webinars including some of the very eminent speakers, Dr. Shahid Jamil, Gagandeep Kang, Soumya Swaminathan, and so many others. Then we have worked on major science capacity building efforts in these last 2 years, especially when we realized that because of the pandemic, the students are not able to attend the classes and coachings. So we have made some workshops, week-long workshops, for preparing them for the competitive examinations in different subjects that include chemistry, physics, biology, mathematics, etc. Some of the organizations, local organizations like Chemistry Association of Teachers, Physics Association of Teachers, were taken into consideration, and we organized jointly. And in fact, I'm happy that these all these workshops, they have seen the huge participation, more than 6,000 registered participants and more than 35,000 viewers on India's YouTube channel, and these are still available on our channel. So this gave a realization that there is a need for such kind of workshops for the students who are looking for their next step in their career. Continuing to this, as I mentioned, we do emphasis on the regional languages and other languages also, Hindi, including Hindi. So we have worked jointly with the DST Rajasthan and India Vision Foundation for various kinds of programs. With the DST Rajasthan, we have organized an internship for their 60 UG and PG students in 2020 as well as 2021. We organized webinar series like Popular Science Talks, especially in the Hindi for these Rajasthani students, and there are several other programs. As I mentioned, we promote the Indian science journals, and we have already edited 3 special issues of Proceedings of INSA, which is now a Springer Index journal. And 4th special issue is now currently on. Call for manuscript is there. One can submit the paper into this special issue of Proceedings of INSA. We have also edited the Resonance special issue in September 2021, which is a popular science magazine, which is more for the school students. This is just some of the lectures we have organized in SIPP series, as I was mentioning, Scientists from India's Past and Present. In international collaboration, we have done various events, especially with our young academies of Southeast Asia and South Asia countries and Asian countries. And we have organized the SciArt image competition, as I was mentioning. This is something very creative and very unique competition for the graduate and PhD students. Then there are several academies meetings with these National Young Academy of Nepal, Thailand, and worldwide meeting, Asian Women's meeting. Our members have participated. This is a very unique science communication competition we started last year, 2021. And this we called Saransh. It's basically a thesis presentation in 3 minutes. So it's basically a national level competition for the PhD scholars, and the medium is English as well as Hindi for different disciplines like physical science, chemical science, life science, engineering science. And what is basically the unique thing about that, in 3 minutes, you have to communicate about your thesis, that to a general audience, not very technical jargons. So very, very simple language, you have to communicate the overall essence of your PhD work. And believe me, this is much more difficult than presenting your regular seminars in your exams or thesis for half an hour or 45 minutes. And this was sponsored by Anton Park. And this will be continuing as a regular activity for INEAS. To promote the research excellence at various levels, we introduced the INEAS National Awards last year. In the first edition, we have given 3 awards, like in carbon materials, nano innovation, and the natural nanofibers, depending on the sponsors. And this year we have added 2 more categories in best PhD thesis in the electrochemistry and the interdisciplinary research, which is dedicated for the university students. As I was mentioning, National Frontier of Science meeting. This is a 3 days annual meeting, which is generally attended by the around 40 young leaders of science, less than 45 years, where they do discuss, deliberate, and collaborate through various interdisciplinary topics. You can just see in 2018, we have interdisciplinary topics like medicinal chemistry, astrochemistry, optical physics. In 2019, which was organized in Samod Bagh, Jaipur, we have life on edge of earth, technology in agriculture, computational chemistry, behavioral ecology. So this meeting is basically a residential meeting, and we make it not just too much of technical, but something more emphasis is more on the discussions rather than only presentations. And as I mentioned in the beginning, we are going to organize third National Frontier of Science meeting 2022 next week in Himachal. We also released 3 white papers in last year. One was impact of COVID-19 on PhD students. This was based on the survey for more than 2,000 PhD students in the country. And we have made a summary of our recommendations. And some of these recommendations are already met by the government officials like DST and DVT. Fostering curiosity-driven fundamental research in India, in which we have highlighted that there is a need for improving the curiosity-driven research rather than just focusing only on the technology development. And the latest one on the career challenge for the young independent researchers, which is very much appreciated by all top scientific community. Scientific and policy-based lectures we organize in our annual meetings. I'm not going into the detail. So every year we have a general body meeting, and also from last 2 years we have started the mid-year meeting in which we talk about various aspects of themes. Like say 2021, the theme was communicating science need of the time. And similarly, this time we have a panel discussion on science performance indices, need, rational, and alternatives. When we talk about the science performance, H-index, citations, I think there is a need to relook into these matrices, because the scientific social responsibility, which we all talk about, especially from the rural perspective, this is generally overlooked when we talk about the science performance. Here are some of the lectures. We have invited Alexandria Elvekian in our last media meeting to talk about the Sci-Hub, to know her perspective about the science journals and open access of aspect of it. Science Day we organize from last 2 years, 4 years in fact, from jointly with INSA. This time we just had, and on the National Science Day, we release our in INSA's newsletter in various regional languages. This time we have released this last week in 7 languages. You can see this right from Marathi to Malayalam and Tamil and so many other, Konkani and others. As I mentioned in the beginning, we have a special focus on the gender inclusiveness right from the beginning, and that is reflected that about 30% members are are women, and even at the leadership level, 5 out of the 9 CC members are women. We have given special scholarship for data science workshop for women researchers. We organize Women in Science event jointly with the Punjab University. And tomorrow, on the eve of the International Women's Day, we are going to release a compendium of our women members of INEAS, highlighting their journey and achievements. And also, tomorrow we are organizing a workshop on addressing the gender bias in the academia. These are some of the events. So now let me come to the local chapter. So the idea of local chapter was initiated 2 years back when I took as a chair. And the idea was that we reach out to the more rural areas, semi-urban areas through our local chapters, which may not be possible right from the cities like Delhi, Mumbai, Hyderabad. So what we have done, we have formed 7 local chapters like NCR, Chandigarh, Northeast, Hyderabad, Mumbai, Lucknow, Kanpur, Kolkata, Bhubaneswar. And the mandate of these local chapters was to collaborate with the local organizations at the ground level and spread the word and spread the scientific awareness through various ways in the community. And I'm quite happy that in last 2 years, our local chapters have really done very well. You can see a lot of events INEAS has done. Let's say, for example, this Chandigarh chapter has organized several events with the Punjab Engineering College and Nasi Chandigarh chapter. Our Mumbai chapter has done a lot of events in the rural areas where we talk about the various, like for example, this workshop was on the robotics and programming for the rural children's. There are some other events by local chapters, and again there was a series of experimental demonstration of science, like in terms of physics, chemistry, and mathematics by our Mumbai chapter, where they have demonstrated. You can see, and not only they have demonstrated in the schools, but they have also telecasted on the Zoom so that it can be reached to as many as possible. They also organized a child congress, National Child Congress in Maharashtra. Again, there are some science communication in the regional languages. This was a workshop on making the microscope from the papers for the rural childrens, just to ignite them. The idea is to ignite them. There is a lot of talent. We all, I think, appreciate that fact, but there is a need to nurture that talent and ignite that talent. That is what we are trying to do. As I mentioned, science camps from the school children. We have done it remote areas of Rajasthan like Churu, Faridkot, Chandigarh, Srinagar. So science camps are not only limited to rural areas. It is also limited to it is also in semi-urban areas as well. And but of course, in last 2 years, we could not do much science camps because of this COVID. But in 2019-20, we organized 12 science camps, and in which we were able to contact around 1,000 students. Then, as I mentioned, Children's Science Congress that was just organized a few months back in Kolhapur. There are some villages in Kolhapur, Nool, Nesari, Besaraj, and Halkarani villages. They were involved, and this was very successful program, Bal Vigyan Sammelan. There are again, so now in the last October to December, we were gotten a very short opportunity to interact and again revamp our in-person science camps and remote area lectures before the third wave started. So we did some events in rural areas of Banaras, and we organized the motivational lectures for them. These are remote area lectures. As I was mentioning, remote area lectures we could not organize much. Just last 3 months we have organized, but 2019-20 we organized 34 remote area lectures covering more than 2,500 students. These are some of the new initiatives, annual flagship events we have decided. And out of these 6 events, I would like to emphasize on this event, which is mainly for the rural areas. So this we call as RUSETUP, Rural Science Education Training Utility Program. And here, basically, the idea is we are identifying the teachers from the schools and colleges in the rural region of India, which are facing several challenges, including the lack of awareness for many opportunities in the higher studies. And we would like to train these teachers, and we would also like to give some science kits so that they can do the science experiments-based teaching in their respective schools. So this event is going to be launched in May, June this year. And target group is class 6 to 8, 9 to 12, and for college standard. And the action plan for this is we are going to collaborate with the district education officer, and we will be awarding the participating schools by providing the science kits, establishing the small demos in their labs. And also through that, the idea is that that lab can work as a model science lab, and that will be as a nodal point for the nearby schools where they can make regular visits to have these kind of science demonstration experiments. With this, I would like to finish my presentation. So I would be happy to take your questions or any suggestions which INEAS can take it forward, because we are very young academy. We are also in the learning and evolving. And I think this group of participants can give us some suggestions which we can take it forward. Thank you.
Thank you so much, Professor Chandrasekhar. It's amazing to see the prospects of learning science and technology in different languages, and also the way that you have incorporated it into the rural schools. And even in this pandemic condition, you were able to conduct 34 different projects. And further, you also said about the new programs where you are going to connect it with the, the district administration, and that's the most important step. I feel that we have to take. We have to bring in the Zila Parishad. We have to bring in the Panchayat and other people, and try to focus more towards providing a very in-depth understanding of science and technology in the local context as well as local language. The other aspect that you touched upon was, taking the things, taking the things in a manner that you are not restricting to India alone. You have considered programs, and you have performed these programs in various South Asian countries as well as other reaches across the world. So that's amazing to see that rural India is also taken care of, and you have an holistic answer for the whole society around India as well. Wonderful, sir. Thank you.
Thank you, Dr. Ajay. So I think, yeah, I'm sorry, Dr. Anand. And I think, yeah, I mean, because we believe in INEAS that, I mean, the science education, science awareness should not be just restricted just because of the language barrier. So that is what the idea of our local chapters when we form them. And I think that idea is really working well, that we are able to connect with the rural areas more actively through our local chapters.
I will invite more questions from the audience. If you have, please go ahead. If there are none, I thank you, Professor Chandrasekhar Sharma, for please coming, taking time off this particular thing, and regards to all at IIT Hyderabad too. Thank you so much, sir.
Thank you. Thanks. It's my pleasure. Yeah. Thank you.
Thank you. So we move forward. We move forward to the next session, much awaited session on energy or power intervention for rural areas. For this, I would like to invite the chairpersons, Professor Sudipto Mukhopadhyay and Professor Prasenjit Tribhuvan. Introducing Professor Sudipto Mukhopadhyay. He has been a champion of combustion technology. He owns a PhD from TU Eindhoven, Netherlands. He has a MTech from down south of India from IIT Madras, and he has a BTech from Kalyani Government Engineering College in West Bengal. He has several stints of working with TCS, maybe TU Delft, and also GE. His areas of research are in energy, propulsion, and environment. And his students are working in the area of chemical engineering aspects, ignition, IC engine aspects, propulsion, and computational flow mechanics, and various other areas. And he has special interest in also agricultural, agricultural chemical disinfection of farms. Thank you, sir. The second important chairperson for today is our own convener for the program, Professor Tribhuvan. He has a niche in sociology, and he has graduated out of Delhi University, and he is also connected to various aspects of anthropology, youth subcultures, sociology. He also handles the nodal office of the Sfurti scheme at IIT Jodhpur, where IIT Jodhpur is the technical agency for the Spurti KVIC scheme. I welcome you both, sir.
Thank you, Dr. Anand, for your kind words and nice introduction. So, I now declare our last session of this conference, that is energy and power interventions for rural areas. And we move to the first talk of this session, which is water wheel waste irrigation, water pumping system on Halerjor Canal in Kalahandi, Odisha. It's a 2-year case study which is being summarized and presented here. So I request the recorded lectures to be present, and at the end we'll have question answers from the authors who are present in this podium.
Everyone, my name is Dhalesh Kumar. I have done my master in mechanical engineering from IIT Jodhpur in 2018 to 2020. During my master, I was working on a project called water wheel based irrigation water pumping system on Halerjor Canal, Kelia village, Kalahandi, Odisha. This project was started in 2017 by jointly collaboration with NGO Kartabya, Syngenta Limited and IIT Jodhpur. The calculation and the design works was performed by Mr. Sandeep Gupta sir and Dr. Anand Palapalli sir, and wheel manufacturing was in factory at presence of Mr. Ravi Shankar Tripathi sir, Sandeep sir, and the installation of water wheel at Kelia village was done by Mr. Devaya Swayam sir, with presence of Mr. Ashok Patnaik sir, the director of Kartabya. After that, in 2018, I started working on this project to perform a 2-year case study to analyze the change in attacking angle in last 2 years. So now the problem statement is, in Odisha there is a village named Kilia in Junagadh block district Kalahandi, which is basically a tribal area. There are some farmers who were using diesel and gasoline based water pumps for irrigation in their field for farming of some vegetables like brinjal, tomato, popia and okra. These farmers were not getting benefit of their farming because of fuel expenses. They were spending 45 rupees per day. So an NGO called Kartabya from Palandi, Odisha and the agriculture company Syngenta came together to help these poor farmers. For this project, they come across the work done at Krishi Vigyan Kendra, Sonipat, Haryana under Haryana Agriculture University, Hisar. They installed a 3.5 kilowatt water wheel, which is sewage from Sonipat to Haryana Yamuna River for irrigation of horticulture crops at Krishi Vigyan Kendra. So basically the idea comes from here to install a water wheel in Kelia village, Odisha. So now we will understand that what is water wheel. So basically water wheel is a environment friendly hydraulic machine. It utilizes the energy of flowing water and the kinetic energy of water converts into mechanical energy and then electrical energy. So the water wheel can be used for producing electricity and for irrigation in farming field. So there are mainly 3 types of water wheels. As you can see, the first one is a overshot water wheel where water comes from upper part. And the second one is a undershot water wheel where water comes in ground level or on base. In the third one is a breaststroke water wheel where water comes at a certain distance, or we can say the half of the wheel radius. Now the similar examples of undershot water wheel. This 5 kilowatt water wheel installed in 2002 at Semra Bujurga village in Lalitpur, Uttar Pradesh, with the collaboration of the village panchayat, Cement India and IIT Delhi. Similarly, in South Africa, a 4 kilowatt installed with the collaboration Food Agriculture Organization, Cement New Delhi and IIT Delhi. Now this is the concept of water wheel. As you can see, this is the water wheel, and this is the open channel, and this is the runner, and this is the shaft which is connected to the water wheel and the gearbox, and this gearbox is connected to the centrifugal pump. When the water is attached to the vane, the wheel start to rotation, and due to wheel rotation, the shaft will rotate. Then the gearbox start to run, and then water pump start to pumping the water from the river to the field. Uh, Now the site condition, you can see this is the Haler Jor stream, Kelia village. This is the Haler Jor stream during rainy season. This is the actual water wheel which is installed in Kelia village. This is the picture when I visited Kelia village in 2018. The civil construction of open channel. So open channel is basically when the water flows in open atmosphere called the open channel. So here the civil construction for open channel is the area of the open channel is A equal to B into H, where B is the width, H is the height, where B is the 1.5 meter and the H is the 0.35. Now the velocity diagram and the stone construction. So this is the water wheel. You can see this is the height of the water which is flowing towards the wheel, and this is the 1.5 meter length of open channel. So and this is the velocity diagram. You can see this is V1 is the inlet flow velocity, alpha 1 is the inlet tracking angle, and beta 1 is the blade angle, and U1 is the peripheral velocity. Now these are the formulas we will use for this for calculation of the power due to head, and the flow rate and the peripheral velocity will be calculated by using this formula, and the flow of water will be calculated by using this formula, and this formula for friction coefficient and for viscous flow, and by using this formula we will calculate a attacking angle alpha 1. So alpha 1 we will find alpha 1 equal to 44 degree. This will be the our design angle. Now in practice, beta 1 should be between 95 degree to 110 degree, and beta 2 should be 10 degree to 20 degree, and whirling velocity W2 equal to 0.96 to 0.98 times to W1, and beta 1 should be 120 degree by leg yard design. Now these are the formula. So U1 and U2 should be constant, and if there is friction, then W2 equal to KW1, and by resolving the velocity triangle we will find VU1 and VU2, and then we will find the force applied by jet on the wheel, then the power output of the wheel, therefore F into U, then the wheel efficiency, output power for input power, and then kinetic energy of the jet, and then the jet efficiency or head efficiency. Now the calculation of blade and the vane dimension, you can see this is the length of the vane 1.5 meter, taking jet diameter or jet thickness is 0.15 meter or 15 centimeter. So 3 centimeter for lean period, 8 centimeter for optimum period, and 15 centimeter during first. So depth of vane will be calculated by using this formula. Now the depth of vane will be the 11 to 13 centimeter. Now the number of blades will be calculated by using this formula. So here the number of blades is 16. So D by D is called the jet ratio, and U by U is the speed ratio. Now the geometry description, you can see this is the vane profile. Here the water entering at a 15 centimeter thickness, and this is water outlet. This is wall where AB is the 18.78 centimeter, and angle A is a 44 degree. So now you can see in this diagram, this is the actual water wheel. This part is this part where shaft is connected. So the length of this part is at 29.6 centimeter, and this part is 13.3 centimeter, and this part is 5 centimeter. Now you can see here the diameter of the wheel is a 112 centimeter, and the internal diameter is a 102 centimeter, and the diameter of the internal wheel is a 45 centimeter, and the diameter of the shaft is a 6 centimeter. You can see in this picture, this is the actual wheel which is designed in factory. Wheel manufacturing factory on 12th Road, Jodhpur, and in presence of Mr. Ravi Shankar Tripathi sir and Sandeep Gupta sir. Now the when now the change in angle of attack in the last 2 years. So when water wheel was designed, the initial attacking angle was 44 degree, and at 2018 the measured angle was 46 degree, and at 2019 it was 47.8 degree. So we can say that there is a little change in angle in 2 years after installation of wheel. The change occurred because of some natural reason like a corrosion on vane, or strike by some floating materials are used like plastic bags, plastic bottles, piece of trees, packaging bags, and aluminum cans, etc. So this is the vane profile, which is designed in design modeler ANSYS. So this is for 50 centimeters thickness, taking alpha on 44 degree and 46 degree and 47.8 degree. Now the meshing. So meshing is the process in which the continuous geometric space of an object is broken down into thousands or more of shapes to properly define the physical shape of the object. The meshing requires a precision convergence and the speed of the simulation. And here 2D model of plane is measured by using ANSYS plane 2020 R3, and the meshing is done in form of edge meshing, face meshing, and refinement. The green independence test, here we take 5 mesh size 0.01, 0.02, 0.03, 0.04, and 0.05, and you can see in a velocity and a distance graph, the V2 velocity is the optimum velocity, so we will take a V2 or a mesh size 0.02 as a perfect mesh. So here mesh size is 0.02 and A size is 0.05 for all triangles, and notes here 4574, and the number of elements are 2174. So we will do 46 degree and the governing equations for fluid flow is there are three governing equations. First is the conservation of mass, conservation of energy, and the conservation of momentum. Now setting up the solar and the physical models, and now after meshing, the simulation was done by applying these conditions. Bounding condition is divided into four parts: inlet, outlet, water surface, and the bed wall. Where bounding conditions for inlet will be the velocity will be the 3.6 meter per second, and for outlet symmetric conditions, and for water surface no bounding conditions, and the bed wall no slip bounding conditions. Now the post-processing, after simulation of a physical model by using solver, now need to analyze the velocity contour, pressure contour, velocity vector direction, and streamlines, which is created by using post-processing platform CFD post for all jet thickness 3 cm, 8 cm, and 15 cm. Here the velocity contour and the pressure contour shows the effect of angle of attack and the water jet thickness on inside the vane profile. This is the simulation result shows accurate description of the flow. Now the for 15 cm jet thickness, you can see in a 44 attacking angle the maximum velocity occurs, and for 47.8 degree attacking angle the minimum velocity occurs. So we can say that the velocity inside the vane profile decreases by increasing attacking angle. This is the pressure control. You can see here the large area of the lower pressure. So this is basically because of the exhausted of the inlet jet velocity, exhausted power of the inlet jet velocity. Therefore, the larger area of the lower pressure. This is the streamlines. You can see here the jet circulation, lower velocity. This come as compared to 47.8 degree. So we can say that when angle is increasing, the jet circulation velocity will be increasing. This is the velocity contour for 8 cm jet thickness. You can see here also the velocity inside the vane profile decreasing, increasing attacking. This is the pressure control. You can see the larger area of the lower pressure because of the power of the flow velocity exhausted inside the vane profile. So from the comparison in the jet thickness, maximum velocity attained for 8 cm jet thickness rather than 15 cm or 3 cm jet thickness. This means that optimum performance is observed when the thickness is 8 cm. And you can see here the very large area of lower pressure. So we can say when we decrease the jet thickness and the technical increases, the larger area of the lower pressure occurs. The performance analysis, you can see this is the theoretical value in 2017 is 44 degree. The experimental value of 2018 is 46 degree, and the experimental value of 2019 is 47.8 degree. So by using the various formula we have seen in previous slide, we will calculate the area of the channel, and the flow velocity will be found for all, and the peripheral velocity is speed 50 rpm and 35 rpm and 34 rpm, and the force of the jet on the vane. You can see the force of the jet vane is decreasing in each year. So the maximum is 7.028 and the minimum is 6.623. The power output will also decreasing. It will calculate timing energy, and then power due to head or available power. Wheel efficiency is also decreasing, and the jet efficiency you can see is maximum is 62%, and the minimum is 53.9%. Now this is the percent error. You can see in 2018 7.18% and 2008 is double 14.8%. Similarly for wheel efficiency percent error and jet efficiency percent. Now this is the cost analysis. Yeah, there are 11 farmers and area covered by all farmers are 12 acres and a brinjal for 10 acres and tomato for 7 acres and okra for 1 acre and a coffee for 1 acre. And this is the full expenses for each vegetables. For brinjals 4,800 and for full expenses for tomato 14,000 and full expenses for okra 1,600 and full expenses for coffee 1,600. So total fuel expenses is 22,000. Now the water bill maintenance cost is 6,096 rupees and 508 rupees per acre. So now this is the cost of cultivation of brinjal neat 1 acre. You can see this is the cost of seed, nursery management, land preparation, fertilizers, irrigation. So total cost is 43,608 rupees and the production quantity in quintal is 180 quintal and the price per quintal is 660 rupees. So total outcome is 1,18,800. So we will get net return 76,192 rupees and in usual practice we will get 54,500 rupees. So the additional return per acre will be the 21,692 rupees and for 3 acres 65,076 rupees. You will see similarly for tomato, okra and for coffee. So the net return will be the 2,48,304 rupees. So the water we were designed for 44 degree of working angle, but in last year which seen some changes in 2018. This was the 46 degree and 2019 it was the 47.8 degree. So the 2D geometry of veins will be measured at an angle of the undersoft water wheel where model in ANSYS design modeler and then simulated in ANSYS QM to see performance of the vein in terms of velocity, pressure and streamline profile. The post-processing of this analysis is also performed for the vein. Further improvement of the farmer profits that was observed during the last 2 years since the installation of the this technology is also emulated. This efficiency of water wheel in the last 2 years are less as compared to the initial efficiency. So the net profit in 12 acres we got 2,48,304 rupees till date. Then the wheel has been able to reap benefits beyond the total capital cost of the overall system. Thank you.
Okay, thank you for the presentation. So I now invite the authors of this work to take up the questions from audience. Any questions? Are there any questions?
Hello. Yes, sir.
Yes. Okay, so Mr. Dhalesh is there, right?
Hello.
Yeah. Hello. Yes, I can hear you.
Sir, if please ask some questions.
Yeah. So Danish, I have just the first question that I would like to ask is like, so you compared
Yes, sir.
one to one with the field water wheel and your simulations, right?
Yes, sir.
So how much difference did you observe, like in the performance, what you expected and what the field, I mean, between the field and simulations?
Actually, sir, we have done this is for a 15 centimeter jet thickness and 8 centimeter and a 3 centimeter. So we got, sir, 8 centimeter is for optimum and 15 centimeter for flood. So we are taking here 15 centimeter. So after that, we seen some changes in angles. So the angle change in angle is 46 degree and 47.8 degree. So we have only data of till that the total cost we got at 2,48,304 rupees, and we don't have data next year. So sir, there will be, we can't say that little bit change in cost of farming.
And could you also comment on what type of material was used ultimately for constructing the water wheel, and what do you expect the life or durability of this water wheel?
Sir, for water wheel construction, we use a mild steel so that it can be for a long time because of corrosion, and for shaft we use cast iron.
Okay,
Hello.
fine. And so you expect a lifetime of what, like 5 years or?
Yes, sir. But sir, we do maintenance in each year. It costs 6,000 something, 6,000.
Okay, fine, fine. Okay, if there is any other questions,
Sir.
are there any other questions from the audience? Okay, if not, then I will like to thank again the authors and Mr. Dalesh for being present here.
Yes, sir.
And we will now move to the next talk of this session, that is on socio-economic evaluation.
Thank you, sir.
Thank you. Decentralized rural electrification based on off-grid solar technology in Meghwalo ki Dhani, Rajasthan. So I request the video to be played, and later on we'll take up the questions. Thank you.
Warm greetings to all. I'm Dr. Bula Chaudhary, Assistant Professor, Department of Economics in Xavier's College, Jaipur. I have done my PhD from Malvi National Institute of Technology, MNIT Jaipur, in Energy Economics. I'm very delighted to be presenting my research paper in this reputed conference. The topic of my research is socio-economic evaluation of decentralized rural electrification based on off-grid solar technology in Meghwalo ki Dhani, Rajasthan, India. Introduction. In India, the energy sector is mainly reliant on conventional sources of energy. CO2 emitting dynamics and exhaustible nature of fossil fuels makes electricity through conventional sources quite unsustainable. India has now started shifting towards alternative sources of energy as the entire world is heading towards sustainable development corridors. In order to ensure sustainability and growth in power sector, India has been introducing policies and programs to enhance the development of renewable energy sector. However, rural India is still facing unreliable power supply and unelectrified households. The unelectrified or semi-electrified rural India is deprived of access to electricity supply either due to the complex topography of the region or due to their remoteness, which makes it expensive and infeasible to extend the grid, central grid in such villages. And it's my observation that even if the central grid is extended to such villages, they are just connected to the grid, but they are not electrified. The decentralized renewable energy alternatives, especially the off-grid solar PV systems, now are being increasingly accepted for rural electrification of remote, inaccessible areas. The present study attempts to conduct a socio-economic assessment of decentralized solar PV systems for rural electrification in Rajasthan via the case study approach of village Meghwalo ki Dhani identified in the Barmer district. Review of literature. I have extensively reviewed a lot of literature related to the topic, rural electrification, the government policy, social impacts, technological aspects, renewable energy, decentralized electrification, etc. Objective of the study attempted to conduct the socio-economic impact assessment of the solar PV systems implemented for electrification in the village Meghwalo ki Dhani Barmer, district of Rajasthan, taking 4 broad variables: education, health, income and women upliftment. Research methodology. Socio-economic dynamics studied in the present study are the education, health, income, and women upliftment. The research instruments included detailed survey questionnaire having questions related to the above variables. Focused group discussions were performed with the members of households in the village selected for the study. The village Meghwalo ki Dhani from the Barmer district of Rajasthan was selected based upon the multi-stage cluster sampling method. In the first stage, the districts with unelectrified villages were selected from Rajasthan. From the selected districts, the village clusters with solar PV microgrid system installed were selected. In the next stage, villages with minimum at least having a minimum of 30 households which were electrified by such projects were identified, and from this particular village, because it had all 40 households electrified through PV system, so all the 40 households of this village were taken for the survey in the study. So therefore, the study is based on the primary data which has been analyzed using the descriptive statistics and the pair sample t-test, and to derive the results and increase inferences, the software which we used for the analysis is SPSS. Data analysis, interpretation and discussion. According to the survey, it was found that the occupational structure of the village consisted mostly of the casual laborers and farmers, and a very small portion of households are engaged in businesses or any other activities. Monthly income, the monthly income of the household is significantly low in the village. The household ranging in the higher monthly income are those who are casual laborers, whereas monthly income of the farmers is marginally low as compared to the casual laborers, and just 3 households are involved in the businesses, and there is not even a single respondent who is working as a teacher in the village. Education level of the respondents was analyzed based upon the 5-point Likert scale, and the maximum number of respondents has never attended school, which contributes to the significantly low level of literacy in the village, and not even a single female have attended a junior middle school or above, which signifies highly low level of female literacy. Monthly fuel consumption expenditure, the most significant impact here of the solar electrification, if we see, has been the decline in the consumption of kerosene expenditure on traditional fuel. We see that kerosene is distributed through PDS system and is heavily subsidized, but still we see that based on the focus group discussions we conducted during the study, we saw that the state that kerosene subsidies are of minimal financial value to the poor rural households, because they are not just using it for cooking purposes and needs, but also for the lightening purposes, and the subsidies are based given on the amount per household based upon the cooking needs of those households. So the amount of kerosene they were purchasing was basically they were purchasing in black money, or they were purchasing in black, and the money they had to pay for it was quite high, and thus after electrification it was seen that the use of kerosene for lightening needs has reduced drastically, and thus the monthly expenditure on the fuel has also reduced from up to 36% then 63%. So the result has demonstrated that after solar expenditure there has been a huge decline in the expenditure on kerosene. Information facilities before electrification were very less, and we see that there has been an improvement in the level of information facilities after the solar electrification. So we see that the after electrification, the time devoted on income generating activities has increased, and the time devoted for household has reduced, as whereas it has increased for studies, agriculture, businesses and other activities. Average monthly income earned by the households before electrification was just below 1000 rupees, which has now increased after electrification up to 3000 rupees, and even beyond that up to 5000 rupees in some households. And we see the time devoted for agriculture in the evening was very low before electrification, which has now increased up to 4 to 5 hours even after electrification in the evening time. And they also similarly in the grocery shops, the time was less in the evening, and now it has increased to 4 to 5 hours. The people can open their shops more in the evening time, also increasing in these sales. Family members per household who were involved in the income generating activities has also increased. So we see that solar energy solutions have helped creating new sources of income generation for rural households, and even the respondents are of the opinion that solar electrification has assisted in expanding the economic activities of the households. After solar electrification, the households have entered into new productive income generating activities like handicrafts, tailoring, running small businesses such as vegetable vendor, etc. The farmers and the other household engaged in the small businesses like grocery shop vendors being extensively benefited from solar electrification, as lighting facilities have increased the scope and duration of these activities in the area. They can now devote more time to the income generating activities during the evening, which result in increase of the productivity and income. Also, as the hours devoted on household work has significantly reduced after solar electrification, the number of earning members in the family has also significantly increased, as they can now shift towards income generating activities. To test whether an improvement in overall status of women health and education after solar electrification is statistically significant or not, pair t-test was conducted. Pair t-test will compare the means of overall score of before electrification and after electrification for these variables like upliftment, health and education. Moving on to the impact on women upliftment. The result explains that there is a significant improvement in the paired sample means, and hence the introduction of solar electrification in the village has significant improvement over upliftment of the overall status of women in the village at significance level of 0.05. And after the intervention of solar electricity, women have been benefited at a large scale. They could go out in the evening and attend social gatherings. They get more free time for leisure and other activities. The study shows that in addition, some of the women have started participating in various economic activities as well, such as tailoring and weaving and other creative stuffs during the night time. And as a result, they are now better placed in the family as well as in the society. We see the paired sample t-test here. The significant level is there, and according to the impact on the health, so according to the results of the paired t-test on health conditions before and after the electrification, significant differences observed between the paired means, and this again has shown a significance level of 0.05, and it is reported again that the health condition of household has improved marginally with use of solar electricity. Availability of solar light has also helped the respondents to visit doctors during night in the case of emergency. They have reduced consumption of kerosene, and other traditional biofuels have also laid positive impact on health due to decline in the pollution that causes problems like watery eyes, black nostrils, difficulty in breathing, headache, etc. So use of solar light have also reduced the risk of theft and increased safety from wild creatures like snakes at night and accidental burns from kerosene. The results also have illustrated that collectively all these benefits have reduced the expenditure on the doctor's fee by reducing the number of visits to the doctor as a result of improved health conditions. Looking into the impact on education, again we see there is a significant improvement in the paired sample means, and the significant improvement of education level and facilities in the village we can see is significant at the level of 0.055, and electricity facilitates the school going children to study in a more prolific way due to the extended study hours in the evening. So as a result of the enhanced affordability and the information, the enlightened outlook towards the education contributes to increase in the girl education as well. The study has illustrated that use of the solar light has encouraged education of children of the beneficiary families, which in turn has enhanced their academic performances. Prior to the use of solar lights, children used to use kerosene lamp for studying during the evening. According to the respondents, children used to sleep early at the night due to lack of light that used to hamper their education. Availability of solar light has helped many of these children to study at night, now improving the education and performance and later on the income generating activities. Conclusion and recommendations. Solar microgrid system in the remote village has contributed to improved quality of life of the people, and thus is a good solution for electrification of the remote rural communities in India, paving way for their economic growth and development. Solar intervention has improved rural incomes both at micro and macro level. Reduced consumption of kerosene and traditional biofuels by the household has contributed to healthy inside and outside environment as well. Women and children have been immensely benefited, as is improved by the case as is proved by the case study, and women find it easy to do household activities, and children can devote more time to studies during the evening hours, which has enhanced their academic performances in the schools. Availability of light in the villages have also contributed to the decline in the criminal and unforeseen activities. The present research study has pointed to noticeable positive impact on the socio-economic life of the people of the studied village who had never seen light before solar electrification, and their socio-economic profile was remarkably poor prior to the solar intervention. Thus, it is recommended to carry out such off-grid solar energy projects in other remote villages that are devoid of electricity since decades. It is also recommended that government should extend its skill development programs in these remote communities post-electrification via such off-grid solar projects to make such solutions more economically feasible and beneficial to the rural communities. At the same time, it is suggested to encourage the private sector and the NGOs to penetrate in rural electrification sector using this tested off-grid solar technology in the remote areas. This is the work cited for the research. I stop here. Thank you.
Okay, thank you for this talk. I now invite the authors of this work and any questions from the audience. So anyone from the authors present here?
Yes.
Okay, yeah. So Dr. Chaudhary, so it's a nice, interesting work. I was just wondering, like, what is the sample size? I mean, for this study that you put here.
As it is a case study of one village, so we had covered all the households of the village, and the total number of households of that village were 40. So that was the sample size of this particular case study. Otherwise, it is a part of a broader study, and in that we have taken almost around 500 households in total as a sample size.
Okay. And so I was just wondering because I mean, see, Rajasthan is a very big state, and there are small these dhanis or hamlets scattered. So, what is your like? Maybe you are aware of that figure. That what percentage of population do you think in Rajasthan is still not connected to grid?
In percentage, I cannot just specify properly, but there are many rural households, especially which have the hilly areas, which are in hilly areas or forest areas, and also the desert areas, and where the grid has not been extended. And even if it is extended, the availability of grid is quite poor. It is available only for 1 to 2 hours in a day, and that is quite expensive also. So we have also taken into consideration the economic side or the cost effectiveness of the solar intervention in these villages, and we have compared that with the grid extension and through the economic distance limit. And it was observed that when we extend the central grid to such villages who are quite far away from the central grid areas, and then that was quite expensive to extend the grid, and the cost of solar intervention through off-grid PV systems was quite less, and people has to pay also a little less for consumption of electricity in these villages. So in some of the villages, I also observed that grid was extended and in to few kilometers, and probably then it was realized that it is not feasible to extend it to the village, and it was stopped in between, and then the solar intervention was done by either by government or by the NGOs as a CSR in private sector, also by in CSR responsibilities.
Okay. So this decentralization, what you saying is mostly is being done by government or NGOs, right? I mean, the funding comes from
Yeah, government has been not doing it at a larger scale. It is the villages we have studied in those villages. Mostly it was either done by any of the private organizations as a CSR or by some NGOs. And in this particular village, it was done by an NGO, Gram Power.
Okay, okay, fine. So it will be interesting to know from you whether we have such kind of clusters in our Jodhpur district, where we may also work out or try some things at our end.
Yes, that would be a great intervention for such villages because central grid is quite expensive for them and their needs for electricity are also quite less. So by solar energy, they have to just pay for whatever consumption they are making or only for the maintenance of the solar panels. Rather, when we extend the grid, the amount the villagers have to pay is quite large.
Okay, and just one quick question, what is the means of their, how do they cook? I mean, they are using traditional fuel, like wood and all that, or they switch to.
Yeah, so earlier they were using traditional fuel only for cooking purposes. But when they used to save certain money and the income or was also generated, income generation increased to some extent because of different activities which they were able to do. So then they started shifting to LPG, and also because it is subsidized, they have that money to spend on the LPG for cooking purposes. So now most of the villages have shifted to this rather than to traditional fuel. But otherwise, before electrification, they were using traditional fuel only.
Okay, okay. Thank you.
There was one more observation, sir, when I conducted this study. That time in this village, it was also centrally electrified. So I had a question in mind that whether now the people are using electricity, thermal electricity through the central grid, or they are more interested in the use of solar energy also only. So it was reported that solar energy is more beneficial for them because of the unavailability of central grid electricity all the time, and also they had some minimum amount of payment which they have to make for it even if they were not using it, and rather in this solar they were just paying for the maintenance and a very minimal and amount, and also through the smart metering. So the only amount which they were using was being paid by the villagers.
Okay, okay. Thank you for sharing this nice study. And if there are no more questions, then we will move forward to the next talk, which is on development and decentralized monitoring of smart street lighting system in panchayats from IIT Madras. And I request the next video talk to be played.
Thank you.
Thank you.
Hello all, very good morning. Warm greetings to all participants of 3rd International Conference on Rural Technology Development and Delivery 2022. I am Aishwarya J, Project Officer from Rural Technology Action Group, IIT Madras, presenting this paper on development and decentralized monitoring of smart street lighting systems in panchayats. On behalf of the 6 authors who are listed here, I am presenting Mr. Saravanan from Central Electronics Center, IIT Madras, Mr. Jeevan Das, Central Electronics Center, IIT Madras, Sulochana from Central Electronics Center, IIT Madras, Professor Bobby Jar from Department of Electrical Engineering guiding this project through Central Electronics Center, and Professor Abhijit Deshpande from Chemical Engineering Department and also RUTAC coordinator at IIT Madras make the authors for this research work. So the purpose of this research is to make a smart street lighting system, because street lighting systems make an essential infrastructure, be it in urban or rural areas. It's not just they add to the aesthetics of the locality, but also they are helpful in reducing the crimes and various ensuring safety to the people in, especially in village panchayats and all. So tracking their operations still hasn't been digitized, and maintenance of streetlights in any area, be it rural or urban, it's still a challenge actually. So also there is lack of digital information on their functionality. Despite ICT-enabled projects happening in village panchayat-based projects, there is lack of digital information on how the streetlights are functioning, and even it is not enabled to get communicated to the core stakeholders. Hence, a smart infrastructure for streetlights in village panchayats is proposed, which could be optimally operated and maintained, so that there is minimal cost, be it to the stakeholders, the user, or the environment. The objectives are set such a way is to develop a basic architecture which can then be extended for more functionalities, and primarily we focused on digital monitoring and controlling of streetlights from the main station remotely and wirelessly. No need of direct physical intervention we looked on. Earlier there had been approaches in the streetlight monitoring with individual by monitoring each and every individual streetlight, where private players have been working a lot, including Geo. But here we focused on grouped monitoring of streetlights, so that they can be regulated well with the lesser cost, but with the same efficiency. So this purpose of research came as a problem statement from Additional Collector of Erode District. Among various solutions that we proposed to him as a research team that I mentioned in the first slide, monitoring of lights in groups was preferred by him because it is cost effective. It can still achieve the same level of tracking and maintenance of the streetlights. When even in groups, for such a monitoring module, the cost of one monitoring module was preferred to be around 2,000 rupees. So then with all these inputs from the additional district collector and with our research team, we developed the overall concept of street lighting system. Here you can see that it consists of a microcontroller, a SIM 800 module, and a rectifier, and a current sensor, sorry. So the microcontroller is to initiate the GSM module, and it will send LT-A9M ready SMS, so to show that a local control box is ready to accept any instruction. So here, instead of even before developing the dashboard, we used a local mobile device for getting the SMS, so that this SMS will be useful in switching on and switching off the street lights. So after the street lights are switched on, to understand the current load, the current sensor with precision rectifier was used for the same. The load current is proportional to the number of lamps that are actually lighted. So if any lamp is failed, the current will reduce. So this will be seen on the dashboard, or it will be understood even from the mobile-based SMS. And the SIM here we used while implementing with the stakeholders SIM themselves, we have tapped. While testing it in front of Central Electronics Center, IIT Madras, we used this prototype, and you can see the screenshots of LT-A9M1 SMS to switch on the lights, and when it is switched off, the current consumption has been shown here. The box here is kept open to make visible the components used in this. So as I mentioned, the microcontroller used here is Atmega 328, which is and also one analog channel is used for sensing the current, digital pin for energizing the relay, and communication with GSM modules. SIM 800 module that works on multiple frequencies has been preferred. A current sensor with precision rectifier here is a transformer with a precision rectifier actually. It has an onboard sampling resistor of 1 kilo ohm and precision microcurrent transformer. An adapter, a 230 volt adapter is used to power the microcontroller module. DC to DC converter is to power the GSM module, and relay to connect the light load with the AC mains. So when you see the prices of the components here, it all came up to 2070 as per it has been developed some few months back. So around the same price will still be maintained. So having achieved the target set by the administrators who approached us with this problem statement, we proceeded for ground testing and piloting in Tiruvallur district of near Chennai. So here we initially conducted a scoping study to understand how many such modules would be required in each selected panchayats. So Padur and Pandeshwaram are the two panchayats we chosen. In Padur, 6 such modules were required, and Pandeshwaram 9 such modules were required, but with different current load capacities of that module. So after understanding the number of such modules requirement, we tested 2 modules in these panchayats, and we even instructed the local stakeholders on receiving the SMS and to give the details that they receive, so that in dashboard development, a more better visualization can be achieved. Here you can see from evening 6 to morning 6, how the current, how the lamps are actually consuming current in ampere ampere units. It has been represented. It has been represented. This is from Padur Panchayat of Tiruvallur district. So having done this and piloted, now we have proposed for district-wide implementation, and if possible to more other districts in Tamil Nadu state. So statewide implementation is the target actually. So though the problem statement initially came from additional district collector, since he got changed, we had to move through the Directorate of Rural Development and Panchayat Raj by explaining again the problem statement and its scope for statewide implementation. So because when it is channeled through Directorate of Rural Development Panchayat Raj, they were much appreciative of scaling up this, not just through MSMEs or even private players who could scale up this module development. We can tap the potential of SHGs in respective districts, even 10th or 12th path candidates and with ITI background and all, they could be able to learn this module development, and they could implement by themselves and enable decentralized monitoring of the street light system. So this proposal was well accepted, and the Central Electronic Center of IIT Madras accepted to give trainings to self-help groups and rural youth, which they have been conducting for various other such electronics projects. And RUTAG, Rural Technology Action Group at IIT Madras, promised for selection and mobilization of self-help groups and rural youth in the districts where this project is going to be implemented. So the Directorate of Rural Development and Panchayat Raj guided the panchayat stakeholders, engineering and land departments in piloting this project in the 2 panchayats. Now they are ready to scale it up in the particular district and few more districts also. So thus the state government enable the implementation and still guiding us through the proposals that we have submitted, and in monitoring that, local engineering and land departments along with the panchayat stakeholders, they are helping us out. So what are the challenges in implementation? So when we looked on and had initial dialogue with self-help groups, their willingness to travel for trainings directly to IIT Madras or even to state level nodal center for training by on behalf of the Rural Development Department, that had been a constraint, but still we are figuring out to conduct the trainings to them in even local district collectorate offices, so that more SHGs would be ready to learn such technology development. And there is need to ensure local logistics for them. It's not just training them. We should try to ensure a proper supply chain for them in procuring the components of this module, in fabricating that, and how they are in hand-holding them in the initial stages. Also, there is a need for continuous support of local governments. So when there is change in local governments, if the project attention gets dropped, it would be a problem. So there is need for continuous support of local governments. The process blueprint need to be in place in facilitating the infrastructure and financials. So the conclusions from based on this initial prototype development and piloting is that, so the prototype developed as per the requirement for decentralized monitoring. It was proved to be cost effective and less sophisticated and well understood even with 2 visits to the panchayat stakeholders. Piloting has been done successfully thus in Padur and Pandeshwaram village panchayats in Tiruvallur district. So what are the steps ahead here? It is to train and handhold self-help groups who showed willingness to learn this technology development, right from the components procurement to fabrication, setting the local supply chain for them, and extending this implementation framework not just for streetlight monitoring but also for various other crucial natural and government supported infrastructure and facilities. So we prefer to acknowledge here Mr. Pratik Tayal, the former additional district collector, Erode, Ms. Kavita, superintending engineer, actually the district collector who brought the problem statement. Later when he got transferred, he pushed this to the Directorate of Rural Development Panchayat Raj. Ms. Kavita, the superintending engineer there, took over from, and guided us in proposal development and piloting. Also, the executive and assistant executive engineers in Tiruvallur district who gave the ground support in the 2 panchayats were implemented, and also the panchayat presidents in Padur and Pandeshwaram. Thanks a lot for this opportunity. I will be happy to receive any queries you have on this.
Okay, thank you for this talk on smart street lighting systems. So I now request the audience if there are any questions, and also if someone is from there, from the authors, I think.
Yeah, yes, sir. This is Aishwarya
Okay,
from
thank
IT,
you.
and Saravanan sir is also. Yeah.
Okay, fine. So any questions on? So I was just wondering, like these panchayat systems that you are talking about. So typically, like what are the numbers of street lights that you are trying to work on?
So it is that's what depends on the size of the village panchayat. For example, the Padur village panchayat that we looked on, it's just a population of 1,000 people. We for that 6 modules are required. So almost 6 into 10 some around 70 to 80 street lights were only there. It depends on the size of panchayat, and the other one 12 were expected. So for within one module, we can bring in 10 to 15 street lights based on the ampere and voltage capacities of the particular street lights, because each street light had varying capacities. Yeah. Yes. Saravanan sir can tell. Yeah.
Actually, sir,
Yes.
each village, each streets, they have 10 lights. There are more than 10 street in one locality. There are 10 to 15 locality in Padur village itself. So if you take Padur, they need 6 models because 6 localities are there, which is having 50 street lights with capacity of 15 watts LED lights. In Pandeshwaram village, they have capacity of 36 watts light. What we are planning, we are combining this to make for each every thing we are connecting 50 lights, so that we can consume 1,000 watts for each of these models.
Okay. Okay. So I see a question from audience, Mr. Yashwant Prasad. You want to ask something?
Yes.
Yes.
Ma'am, what is the cost of the system that you have designed?
So totally it will come around 2,000, sir. So if we plan all the things, we will fabricate here itself, then the cost may reduce. Now the cost is 2,000. We can reduce it to 1,500 if all the things are available in local market.
And have you identified some entrepreneur who is going to fabricate or manufacture the system?
Yeah, in this lieu, that's what, instead of entrepreneurs, the additional district collector who first brought in the proposal for this smart street lighting module development, he said that why don't we tap, is it possible to train the local self-help groups to procure these components, fabricate by themselves, so that they get a livelihood out of this, and also it can be implemented decentralized way, and maintenance also they could take care of, further to some trainings to them on this. So instead of entrepreneurs, this has been preferred by them, and we are also trying to pitch this framework as a proposal to the Directorate of Rural Development and Panchayat Raj.
Okay, so what about the servicing and maintenance part? Is it also realized? Has it also
No, actually, now we want to train the locals so that they can do the maintenance as well as the servicing. They can do that one. So we can train the local youth in the panchayat, so they can make the maintenance as well as the servicing.
Okay, so my next question, I have one more question. Can I ask?
Yeah, no problem.
So what profit do you expect SHG group will earn by from each street lighting system, means by from one piece of the lighting system. So is it all, as you are talking about livelihood, right?
So what is the main problem in the existing system now? So they're not having any data or what is the current consumption for the street lights. So they, and also they're not switching on the light in time, because their consumption of electricity is more in the street lights. So they want to reduce this. So the person who is operating, they can switch on that light and switch off the light using SMS, so that the cost for that electricity will reduce.
The profit wise, see, government needs to be the customer for this. So a decentralized maintenance of streetlights is the objective for the government, the rural development and panchayat raj. So let's say some SHGs in few villages are trained, they may be supplying to few other villages or nearby districts also. They can get the capacities to do that, and based on the requirement. So who are going to buy this? The government is going to buy. So by properly setting the margins for that, or a financial flow diagram for this only, the government needs to buy, so that some margin goes to SHGs. So we could propose the margins, and how it is adapted further, we can track and handhold only to certain extent as a technology development supporting agent organization. Yeah.
Okay,
Thank you.
So I see
Thank
another
you.
question from Professor Ravi. Professor Ravi, you may please go ahead. Okay, I think it's not there. So a question from Dr. Bapat. Please,
Yeah,
madam.
so,
Please.
are you able to hear me? Sorry.
Yeah, yes, sir.
Yes. Professor Ravi, please go ahead.
Sorry, I was speaking when I was muted, so that's why you were not able to hear me, sir.
Okay, no problem.
So my question on this is, sorry, I joined the presentation a little bit late. But are there also plans of integrating a solar module to the street lighting, or is it also already solar street lighting?
No, not all solar, sir. This is a conventional electrical type street lights only, sir.
Okay, because you're looking at low wattage street lighting using small modules. If it can be integrated with solar, probably the renewable energy development agencies like IREDA or even the state renewable energy development agencies
yes, sir, but
can pitch in their capital for doing this.
actually that
Yeah, proceed, sir.
actually, sir, that the panchayat has to decide, sir. But now panchayat, they are using only conventional energy. They are not going for solar energy. If they wish to go for solar energy, they can implement that in solar energy also.
Yeah, if solar is implemented, then there is actually a scheme for support of that from the renewable energy development agencies, and some money can come forth from there. That's what I was trying to.
Yes, you can reduce the cost, sir.
Yes.
There's a question from Dr. Bapat. Madam, please go ahead.
Just wanted to add on to that, as Dr. Ravi also has said, but the solar panchayats are not ready for solar, but nevertheless, my suggestion is following. Maybe whatever your pilot experiences or how successfully you have implemented it, maybe one two-pager can be sent, and the proposed plan, whether it is implementable at different states or which type of lights and other details, the suitability of your technology elsewhere also, that needs to be highlighted. And for this SHG, because see, for a government to procure or something to make policy decisions, it may be little time taking or certain things we do not know, but we can make an attempt to pass this information to them, and through PS's office we can try to have presentation or dialogue with you all to ministry people. That is from my side. Thank you.
Thanks a lot for that
Thank
work.
you, madam.
Yeah, as you mentioned, we'll try to share a broadened concept note for a wider implementation of this framework. Yeah, thanks a lot
and
for the inputs.
and remuneration or the financial part, you need to mention it very clearly. If we are
Yeah.
really making impact, one is that livelihood option for SHGs or some other option for SHGs. And suppose if government is not procuring, see in Gram Panchayat, they may be having funds at Panchayat level, and that Gram Sabha or Panchayat level, they can decide, and then so there are there are so many ways ministry or other people can think, and we can take it ahead. Thank you.
Sure. Yeah. We'll put the financial details also to that.
So thank you again, Sarvanan and Aishwarya. So
Thank you, Professor. Yeah.
So we go forward to the next talk, and which is the last talk of this session on improved earthen tawa firing process from IIT Delhi. And I request the video to be played, and we'll follow with the questions.
Good afternoon, everyone. I'm Yashwant Prasad. I am currently pursuing my PhD at IIT Delhi in Mechanical Engineering Department under Professor M.R. Ravi and Professor S.K. Saha. The topic of my presentation today will be improved tawa firing process. Basically, chapatis these tawas are generally used around across the countries in various villages, and around 10 to 11 potters families in Pochri village of Bharatpur district Rajasthan are involved in making tawas, and they earn their livelihood by making these earthen tawas. So basically they make around 150 tawas per day per person, and after making it they sell it to the traders at wholesale rate of 3 to 4 rupees, and the traders then sell to the end users at rupees 10. So making tawa, there are 3 processes, starting from mixing material, forming tawa, and finally firing it. So the tawa is made by mixing chikni mitti, which is clay, and bajri, which is red stone powder collected from nearby village. They are mixed in 1:1 ratio, and tawas are then formed manually using hand tool and a mold, as you can see in the figure. And these formed tawas are kept under the sun for drying, and after drying, firing is done. So traditionally, the open firing process is carried out where around 3,000 to 6,000 tawas, based on the size of the family, and they prepare open firing field where tawas are stacked along with the fuels. Those are mustard husk, dung cakes in 8 different layers, and finally all the layers are covered with mustard husk from all around, and from the top dead weights are placed. So this open firing process generally takes 3 days to complete, around 72 to 80 hours. So one of the open firing process was observed in the field from one potter's family. So around 3,000 tawas were fired, and dung cakes around 370 kgs and mustard husk around 420 kgs were used as fuel in this firing process. The thermal efficiency of this firing process came out around 8%, and after firing around 20% breakages were observed in tawas in the form of cracks. So based on the observation from the field and research conducted in the field, 3 problems were identified related to firing. First one was long firing cycles, which takes around 3 days to complete, huge fuel consumption, around 800 kgs of fuel including mustard husk and dung cakes are used for firing 3000 tawas. And lastly, large amount of breakages were observed after the firing due to or in the form of cracks. So the objective of the project was defined as to develop an efficient tawa firing kiln in order to increase the savings of tawa making potters by reducing firing cycle time, fuel consumption and breakages observed in tawas. So the team collected the unbaked tawas from a field, and samples were prepared of size 5 centimeter by 5 centimeter in order to check the suitability or check the possibility of reducing the firing cycle time. So a muffle furnace was used, which was a controlled temperature controlled muffle furnace, where the unbaked tawas samples were baked for 6 hours, right from the beginning from the room temperature. It was increased at the rate of 1 degree per minute for the first 2 hours, 2 degree per minute for the next 2 hours, and 4 degree per minute for the last 2 hours. And the baked samples were observed, and the color change was where the color changes were observed. Also knocking the samples, ringing sounds was produced. So this confirmed that the output was as per the desired quality requirement for terracotta baking or firing. So it was confirmed that shorter firing cycle was possible. So the next step was to identify the existing kilns across the country that could be used to fire tawas. 3 different kilns were identified, out of which 2 were already were being designed and developed by Rutaga RTDD. One was installed in Khurrampur village and another was installed in Uch village. These furnaces were used to fire pots, saucers, flower pots, etc. The third kiln was from Bhuj, which was specifically used to fire tawas. So among these 3 kilns, kiln from Uch village was selected for the trial firing of Poonchri tawas, as Poonchri was very closer to Uch village and transporting was comparatively easily when compared to all the identified kilns. So the performance of Poonchri tawa, the kiln by firing Poonchri tawa was conducted tested by conducting firing of these tawas in kiln of Uch village, where the potters from Uch village and the Poonchri village and also the NGO partner Lupin Human Welfare Society participated in this trial firing process. One layer of stacking of tawas was done where 420 tawas was stacked. Around 1 hour was consumed for stacking these tawas into the kiln. Sawdust around 50 kgs were used as fuel, and the firing time was just 1 hour. After the firing, only 2% damage was observed. So this observation gave us confidence that this kiln is suitable with some modifications in order to fire tawas which are made in Poonchri. So the design team decided to develop this kiln and construct this kiln for testing and testing in Poonchri village. So just the height of the kiln above the grate was modified. So it was kept around 22 inches so that multiple layers of stacking could be done, and the trial could be made by testing the kiln with stacking it with multiple layers. This kiln was tested in Poonchri village, where initially the trial started by stacking single layer of tawas. Around 600 tawas were accommodated in single layer, and then we increased the number of layers of tawas to enhance to check its performance with multiple layers. So 2 layers were tested and finally 3 layers were tested. In 3 layers around 1900 tawas were stacked, which took around 2 hours in order to stack. And the fuel that were used for firing were firewood, which was around 10 kgs, and sawdust, which was around 165 kgs. So firing was done and completed within 2.5 hours, and the thermal efficiency of this furnace came around 21%, and the breakage was around 3.6%. A calculation on saving was done with respect to firing 300 tawas. So it can be observed that with respect to firing cycle time and field preparation or kiln preparation time, there is a drastic reduction. Field preparation can be completed within 3 hours, while firing can be conducted every days, that is every 24 hours. Also, there has been around 16% reduction in breakage, and because of which there is a saving of around 1900 to 2000 rupees per 3000 tawas. Also, due to reduction in fuel, there is a cost saving of around 1200 to 1300 rupees. So in total, in single firing of 3000 tawas, there is a saving of around 3000 rupees. And for firing 9,000 to 10,000, a potter's family with 2 members can save around 8,000 to 10,000 rupees per month. So there has been considerable improvement in terms of the firing efficiency, fuel consumption, that is fuel consumption, and time requirement or time consumption for firing, and the breakage reduction after the firing. So the newly developed kiln also does not require dung cakes, as these dung cakes there is a scarcity of supply with respect to the demand, and due to this scarcity of supply, there is the price of these dung cakes are increasing day by day. So now with this kiln, dung cakes are not required for firing as firing fuel. So there is considerable saving in terms of capital cost and time. So currently the fuel has been tested by using mustard husk, has been tested by using sawdust as fuel, but mustard husk is a fuel which is abundant, easily available and cheaper. So this kiln is currently in field trial phase, where in future we will also test the kiln by using mustard husk as fuel. And after modifying the design as per the feedback, a design drawings will be finalized, and this design will be shared with our NGO partner for its construction in future for the villagers. Thank you.
Okay, so thank you for the interesting talk. So now invite, I think Mr. Prashad is already here. So any questions from the audience?
Yeah, I would like to ask, congratulations, Yashwant, and congratulations to your guys also. So my questions are only 2 things. One is that earlier also IIT Delhi has showed the kiln for bangle making and all. And what was actually I felt interested in, that it is making the process easier, at the same time it is saving the fuels also, and of course it is impacting the remuneration or the saving also. So now this kiln you have designed for tawa making at particular location. So whether if you want to replicate this kind of a kiln is also very important thing, and if you are considering this Rajasthan or many artisans, then how can we replicate the same, whether any uniformizing the structural thing or any other things, and then only hand holding, whether it is possible, and how best we can replicate and what we need to do over.
Thank you, ma'am, for your comments. As Professor Ravi is with us here, I would like him to take this question. Ravi, sir.
Yeah, thank you. And it's a very important question Dr. Bapat has placed.
Hello?
Hello, are you able to hear me,
Hello?
ma'am?
Yes, you're audible, Professor Ravi. You're audible.
I think Dr. Bapat seems to have a network issue. Okay, are you able to hear me, Dr. Bapat? You're here?
Oh, I think she's not audible.
Yes. Should I go ahead and answer the question, but she's not here?
I think she's here. Maybe there is some temporary interruptions.
Yeah. So there seems to be some network issue with her. That's why she's not able to hear, and we are not able to hear her now.
Dr. Bapat, can you hear us?
We can ask in the chat to her.
I think, Professor Ravi, you can continue. I mean, she is there.
So the basic design change that we have tried to do in this, of course, open firing and kiln firing is one difference, which is basically responsible for reduction in the breakages and using the appropriate amount of air, because of which fuel savings also happens. The second thing that we have done is to use kiln walls which have an air gap between the bricks. So that is called the rat trap bonded construction. So these are the two concepts that we have introduced into practically most of our furnaces that we have built across the other RUTAG projects as well. The projects that Yashwant was mentioning in his presentation in Khurampur and in Unch village, primarily the differences that we tried to make in the construction was to use rat trap bonding, so that the energy absorbed by the wall, the kiln wall and the kiln floor, is reduced. Okay, so this is the primary change that we have done. And what we actually find is that in a kiln, typically about 150 to 250 kg of pottery is fired, but the whole wall has the weight of close to 1 to 2 tons, depending on the size of the kiln. So if I try to fire them, the 1 to 2 tons would absorb about 4 to 5 times more energy as compared to the 200 kg of pottery that is there. So in order to reduce that, we introduce air gaps so that only the innermost layer of the bricks in the kiln absorbs heat. The outer layers are not getting hot. So with that, there is a substantial savings in fuel that we have achieved in many kinds of furnaces. So this is a basic concept which can be easily replicated in any kind of furnace across the board. So it can be furnaces for melting metal, it can be furnaces for baking pottery, it can be furnaces for any other purpose. Just to make the walls more insulating and lighter, we introduce air, which is a zero cost insulation in between. That is the whole principle. Otherwise, the present work introduces a kiln which was not present in the traditional thing. So introducing a kiln and rat trap are the two things that we have done. So it is easily replicable across the board, any kind of furnace.
Okay, I hope Professor Bapat, Dr. Bapat, can you hear us?
Yeah, now I think yes.
Okay, so initially.
So was I audible to you, ma'am?
No, actually there was a glitch. I do not know. Sorry about it. If the time,
If the time permits, briefly he can repeat maybe. So if you can allow.
So should I just briefly repeat for Dr. Bapat's purpose?
Yeah, sure, Professor.
Yeah.
So, madam, I just was talking about two things. One is that in this, the traditional firing was done without a kiln, because of which there is a lot of temperature gradient and there was a lot of breakages. So we told them to introduce a kiln, because of which the temperature becomes more uniform and breakages decrease. Second thing is, in all the kilns that we have constructed across RUTAG projects and even before that, we have introduced what is called the rat trap bonding, where in the wall we introduce an air gap, so that the fraction of the wall that becomes very hot is substantially reduced, and therefore the fuel consumption is decreased. So these are the two things, and they can be easily replicated in any kind of furnace across the board. This is what I was saying.
Okay. Thank you. We can connect later on also. Sorry, there was a glitch
Sure,
from my
ma'am.
side.
Anytime. Yeah.
Sorry about it. Thank you.
Thank you.
So, Professor Saha, you
Yeah,
have,
just I could have asked internally also, but I thought many participants are there. So Ravi, can there be a design chart be made for specific requirement so that it could be easy to duplicate?
Actually,
Very right.
rather than a design chart, what we have now practiced all through in the past is to keep the dimensions and the firing methods of all the kilns practically nearly the same as the traditional method, and we only change the construction method of the floor and the wall. So that can easily be documented and given to any person, and maybe in 1 or 2 day workshop it can be demonstrated to construct a new kiln also anywhere we go. So that is the thing which can easily be done. So we can prepare a documentation and we can also demonstrate on the ground.
Thank you.
okay. Any other questions? Okay. So I had one question, but I think Professor Ravi already clarified it, because I was wondering, like, what is the cause of breakage? Is it uneven thermal gradient or the structural loading?
It is uneven thermal gradient.
Okay. So that is taken care by the new furnace. Right?
Correct.
And so it's a natural draft, right? I mean, there's
Yes,
no...
yes, it is a natural draft furnace. There is no forced airflow in this. Basically natural draft.
Okay, and that is good enough for handling the combustion, because I am seeing that you're using a lot of fuel, because I mean, sawdust occupies a lot of volume, right? So you're putting a lot of sawdust in there.
Yeah.
So that fits in there.
Yeah, actually, people sit near the furnace and keep throwing the sawdust into the fire at the rate at which they need. So this is manually fired furnace. So it is not all dumped in one go, but they just keep throwing it into the fire hole as required to maintain the temperature.
Okay. So if there are no other questions, then I would like to thank Professor Ravi and Mr. Yashwant for this talk. And we come to close of this session. And I thank you all for joining, and we will have now the closing ceremony. But before proceeding to closing ceremony, I would like to summarize the what our activities were over the last couple of days. So the conference started on 4th of March, and the inaugural program started with a ceremonial lamp lighting, which was followed by Director IIT Jodhpur's welcome address. Professor Chaudhary spoke about the importance of working directly with the rural communities and the role of IITs in this process, and also other technical institutes across the country. The welcome address was followed by an inspiring inaugural address by Professor R. Chidambaram, who is also the Chairman Board of Governors IIT Jodhpur and one of the initiators of the RUTAG while being at the office of ESA. So Dr. Chidambaram reflected on the science and technology of experts working directly in the villages, and he spoke about the necessity of having a close relationship with at the grassroots level people. He also talked about the importance in the context of today's world, the scientists and social scientists are working together to find solutions to the pressing problems of the country. Then the inaugural address was followed by our mentor, Dr. Bapat, and she traced the history of RUTAG and RTDD conferences, the third edition that we are doing currently, and previous two editions. And she stressed on the use and significance of having periodic meetings to reflect on the work done by the RUTAG chapters. Then we had the fortune of having the mentor address by the plenary lecture by Professor Saha from IIT Delhi, who is also leading RUTAG IIT Delhi. So he spoke about the enabling work that is taken up by RUTAG Delhi team with the local communities, and he also talked about the possibilities of working as part of RUTAG initiative. This was followed by the Dr. Anand's talk on the concept of RTDD and the way forward with the conference. And finally, I had presented the schedule of the coming sessions. The first session was on the digitization for rural areas. Three papers were presented, which focused on technologies that help digitize the rural sector through various applications like telemedicine, smart vending cart, mobile health applications. The second session was on rural education and skill development, where again we had papers from UTAG IIT Delhi on rural entrepreneurship, IPR, and modes of technology transfer for the rural sector. We had a case study from tribal areas of Madhya Pradesh, which was very interesting and highlighted the importance of communication in the remote areas. The second day, we started with a keynote lecture from Professor Dharmendra Saraswat. He stressed on the artificial intelligence using AI for analysis of the crop health, particularly leaf data, soil data, hydrological data. And he gave some real examples. We also talked about the RUTAG IIT Delhi Purdue collaboration and had a discussion with Dr. Bapat on transferring the apps in context of India, if there is some changes or customization to be done. He also stressed on the collaboration with the agriculture and the social fabric around. This was followed about a talk from Professor S.K. Kapoti, Deputy Director IIT Guwahati on rural technology for the masses. He also shared many practical things that has been developed and technologies intervention for the rural masses. We also saw examples like this session, in this day session, that talks on Tulsi Mala bead making, which has been used and popularized successfully in UP and Gujarat. And we also looked into the restoration of marketing techniques for the rural areas. The other talks focused on the Vilva decortication, pomegranate extractor, aloe vera processing, and wool processing that was developed also at IIT Delhi. The next session on water management was chaired by Professor Tiwari, and there we looked into technologies to analyze the groundwater using indigenous developed technology. We looked into agriculture machinery for paddy, which consumed quite a significant, less water for irrigation. We also saw technology for seed ball making for the agriculture. We had lastly we had the assessment of the designs being stressed by Professor Bhaduria from IIT Kharagpur. And this was followed by the talk by Professor Anand Rao from IIT Bombay, where he was talking about the energy applications for site-specific situations. He also stressed upon the energy effectiveness that we need to consider. Lastly, we had discussions, also panel discussions, where Professor Vaduria explained the agricultural diversification and technology dissemination to the local farmers. Today being the last day, we started the conference with a plenary talk by Professor Subbarao on Gram Urja Swaraj. He summarized the multifaceted efforts from his group to make villages self-reliant in energy using the available local resources, which included wind, water, and biomass. And this was quite an enlightening talk. This was followed by a couple of poster presentations and discussions. The next plenary talk was from Professor Chandrasekhar Sharma, INEAS, detailing the various efforts in online education, particularly their utility during the pandemic. And finally, we had the energy and power interventions, the current session that is going on for rural areas, energy and power interventions. And again, this also covered a variety of topics, like we had a water wheel example from Kalahandi, Odisha, decentralized rural electrification based on off-grid solar technology in Rajasthan, decentralized monitoring of smart street lighting systems in panchayats from south. And lastly, we just concluded with the talk of earthen tawa firing process, which is quite beneficial for the potters in terms of increasing their income and savings. I also want to mention our first keynote lecture from Professor Winston Soboyo, who spared time and showed very useful and very delighting examples from Africa. And he also stressed on the important collaboration between US, India, and Africa. And we also cherish his kind words and appreciation words on Indian science and development. We have been streaming on YouTube all the 3 days, and these videos will be available online and can be accessed if you had missed any of the lectures, talks, or due to network connectivity. Okay. So I hope I have summarized, and I apologize if I have missed any of the talks or contributed lectures. However, we have all thoroughly benefited from this gathering over 3 days. And now I hand over to Dr. Prasenjit Tribhuvan for the closing ceremony of this RTDD 2022 edition. So thank you all for joining us and being there, and let us continue with the closing ceremony, which also will discuss some important aspects. Thank you.
Thank you, Dr. Savitro. So after 2.5 days of engrossing and informative sessions and very inspiring talks, we have arrived at the closing ceremony of this important conference. To start off the closing ceremony, I welcome Dr. Ketki Bapat from the Office of PSA for her remarks.
Thank you, Dr. Prasenjit. I hope I am audible because there is some glitch from my side, so apologies for that. Is it okay now?
Yes,
yeah, we can hear you.
Okay, thank you. So good afternoon to one and all the participants, dignitaries, and esteemed guests. So really, it was, let me express my earnest thanks to Dr. R. Chidambaram and Professor Shantanu Chowdhury for their wholehearted support and guidance for conducting and organizing our RTDD 22. And really, it is a commendable to have these sessions and listening to the dignitaries. It was a feast. Also, I would like to express my thanks to the entire RTDD organizing team, or very nicely they have convened also. And to mention Professor Anand, Professor Sudipto, Professor Prasenjit, Professor Singh, and so many other which I may not be knowing. So thank you all for organizing this very nicely, and really delighted to be a part of this conference in every single aspect. You people have nicely, I mean, the theme of RTDD was really nicely amalgamated the topics which are relevant to the today's rural areas. When we are seeing this COVID kind of a thing, or the connectivity usage, really all the topics right from the apps, artificial intelligence related to the artisans, very well really coordinated and thematically arranged. And few of my observations are that, what I was really very happy to note, that the people at ground level, they really require the technologies, and also they are ready for that, to accept the technologies. And this is really, credit goes to the silos efforts for can you just I have to open the door, please 1 minute, huh? Yeah, sorry. So what I like, the readiness for technology absorption and translation. And thanks to the efforts done in silos by many institutions, SSGs, and other at ground level also. And the prototypic or the limited prototypic efforts and the limited validating efforts also were well documented and well presented in a scientific manner, where we can use them and then give the confidence at the ground level and show this observation. So that was really a delight. Even students from IITs and many other institutional organizations also, they really opted to work on the rural problems, which are really painstaking or the pain points at the rural thing. And really credit goes to their motivational guide, Professor S.K. Saha, and many more at their our all RUTAC centers, TIs, and many other motivational guidance. So really very, it was very nice change to know that people are also getting connected to the local problems. And also to take it forward, my suggestions would be, or we can work on that. Suggestions are as follows: that these are the ready technologies, or at pilot level, if they have demonstrated in a very promising way, such kind of a thing, such kind of a technologies we can escalate, and we can disseminate to the or wider outreach we can do. And if any tweaking or any other newness or any additions to be done, maybe all of us we can work together and take it further. From PSA's office, any other thing, as I was also suggesting in between also, the things which are to be pass it on to the concerned ministry, or for further dialogues or further their opinions also can be sent to us. And I can, PSA office can connect to the ministry level. And as we are actually having this RTDD conference organized by IIT Jodhpur, and if we are considering the Rajasthan as a state, and those priority areas can be taken, the center's vision is also working on the Center for Emerging Technologies and Sustainable Development, already well established, and lot of already work is happening in terms of good connectivity. Even many series you people have organized to discuss about the topics, and also these kind of endeavors can be taken to the next level for better connect, and we can work together. So thank you, and that is all from my side. We are all there every time, no problem. PSA office is there and RUTAC centers are there. Thank you all. Thank you. Namaste.
Thank you, Dr. Bapat. It has been wonderful working with your invaluable guidance, especially of the initiative that you took before the start of the conference to meet the local NGOs. It helped us to open up new opportunities to work with the local communities and to engage with them. Thank you so much. From here, I would request individual RUTAC centers to please come forward and give their remarks. I would first request members from IIT Delhi RUTAC Center, the representative from Professor.
Okay, thank you, Prashanjit. So maybe I and Ravi will share a little bit. So I have a single point agenda basically. As a teacher, I think we should be researchizing these problems, and as I was sharing my thoughts with Dr. Bapat the other day and with many others, unless we mobilize our research community where we are placed as a teacher, and this multiplication would be very difficult. I can, as an engineer, I can do a couple of designs, 5, 10, but then percolation down and multiplication is a challenge, as all of us are facing it actually. There are not only technological challenges, technical challenges, social challenges, marketing challenges, right? So the gestation time is very long actually, that even Tulsimala is one of my earliest work with RUTAC IIT Delhi. I started 2009, and it is almost like 13 years, sorry, 2014, it's like 8 years, not even, it is just raising its marketing things slowly, but not to. So my suggestion as the faculty of various IITs, we should, while developing this thing, we should keep our mind to convert this thing research activity, so that we can bring mainstream, BTech, MTech, PhDs in this domain, and hoping some of them will become entrepreneurs, take it as a research, and that way I think it will be like in wildfire activities. So with this, I wish RTDD was initiated with that kind of motivation in our mind, and I'm sure RTDD will see many more versions in futures, and it will become a key research areas, not only for India, for the world. With this, thank you, and all the best to IIT Jodhpur for nicely conducting in such a short notice. Thank you. Bye-bye. Ravi, you can add.
Yeah, I just wanted to add a small bit here. It is the element of satisfaction that is there in the kind of work that is done by RTAG projects, for not just the faculty mentors that are involved, but also the students. So if you get the students to taste that feeling of, they design something, they do some calculations, they make some analysis, and then they go to the field, they implement it and eventually see it working, and then see that, there is this benefit and this is better, that is better, and these are the small changes that we need to do to make it good. And at the end of the day, whatever they designed and worked on actually is working in the field and people are benefiting from it. That satisfaction that the student gets, if it is a BTech student or an MTech student or a PhD student, these people, when they go to the field and see that, yes, we can actually make things happen in the field, that makes them a complete engineer. That makes them a person with full confidence that, yes, it's possible for us to do this. So RTAG actually presents them with opportunities which are low-hanging fruits for student community, in fact, because there is so much to do in the rural sector in the country that even with rudimentary inputs of engineering, the changes that happen in the field are substantial. And that then gives the students a satisfaction that itna chota humne kaam kiya, whether such a small input we have been able to get this kind of a satisfaction. If I put in all my engineering abilities into it, how big can it be? And that satisfaction that the student gets, and the fulfillment that faculty member gets from seeing the thing implemented in the ground by students, is a reward in itself for the whole this one. So on one hand, yes, we try to use cutting edge methods and tools and techniques and research to implement projects in villages. So the students get trained in all of those while doing the implementation. And on the other hand, they are also getting the rewards reasonably instantly. And that combination is a beauty of rural technology. And that's something which we should get the students as well as even faculty colleagues to taste once. And once they are into it, then, like Professor Saha said, the wildfire, the sparks are there all over, and it can actually spread. So this is one of the things. And the second thing that we need to look at is, again, Professor Saha mentioned about this, that taking a technology from the laboratory to the field has a set of processes in place in the industry. But when we come to rural technology, those processes need substantial changes and modifications. In fact, that's the topic of Yashwant's research project that he's doing for his PhD. See, the volumes that you are going to get are not big. In industry, actually, you are talking about, maybe a design of a mobile phone, and you're talking about millions of pieces being sold. Whereas here, you make all of this effort, ultimately, the number of people that would actually be able to use your technology might just be about 20, might be about 40. But then what is required is to be able to build that capability into those people so that they can fend for themselves in future. And then you move on. And like Dr. Chidambaram used to say, every 100 kilometers, the technology changes. It's the same pottery kiln, but I do it in Bharatpur. It's something, if I move a little bit away and go to, let us say, Agra or Mathura, then the technology required will need some tweaks, some modifications, and then the locals would not be able to do that by themselves. But then you put them together, like what we did in this particular project that Yashwant presented. Unch is a village which is just about 30-40 kilometers from Poncheri, or 50 kilometers from Poncheri. So we basically took the potters from Poncheri to Unch and let them interact with each other, and then with their help got a kiln built in Poncheri. Now there is this communication between those potters, and they took each other's phone numbers. They can talk to each other, they can figure out. So their own heads are put into it, and then we become redundant after a certain point in time, and that is the purpose. The purpose is that we should become redundant eventually, so that we can move on and light this torch in another place which is another 50 kilometers away. Right? So this is the difference between technology development in the rural sector vis-a-vis the industrial sector, where you go from TRL 1 to 9 through a set of processes. Here you may not need to go through practically all of those TRLs, but then the important thing is to be able to get the technology enabled in the ground to set and propagate by itself organically. So this is basically what I wanted to share, and there is a reward in it for everyone that actually comes into it, and that's the beauty of it. Thank you very much.
Thank you so much, Professor Saha and Professor Ravi, for those invaluable comments. We shall now invite members from the IIT Madras RTDD Center to please.
Professor Abhijit, are you there, or shall I?
No, please go ahead. Actually, I am away from Chennai, and so my connection may go off and on. But I'm there listening. So please go ahead.
Okay. So I'm just speaking here on behalf of my team. While considering the way forward, here are my remarks. So RTDD is one of the few centers in IIT Madras or any IIT which works from a bottom-up way. It is not based on the directives that we are working. For us, the steering group of people or the grassroots stakeholders, either by giving the problem statements for the technology requirements, or in validating it, or in using it, and also in disseminating. Building their capacities by through this technology development or in its utilization is no more had been just a conventional means now. Now we have proceeded from just transferring the technologies from lab to farm. From there we have moved on to enabling the lab structure even in the rural environment by recreating these living labs within the rural environment and providing them the possible infrastructure to develop technologies for themselves. The capacity building itself has moved a layer ahead. And again, as dissemination mentioned previously by Professor Ravi, it is no more as a segregated what to say, an exclusive process. It is happening. The impact once created, it is driven much through the local stakeholders who are taken first, who had volunteered in testing the technologies and adoption, and they are actually the torchbearers of dissemination, and we are just enabling it, and we are just part of that ecosystem. RTDD should still keep this technology development and facilitation and core, whereas other possible activities that are adding up while disseminating, if any entrepreneurial support is required, before developing the technology, if any socio-technical validation is needed, if any managerial work we are working, it should all be the connecting points to that. But still, this technology development and facilitation should be the core of that, and we need not digress. And if RTDD follows that intensely, vertically and horizontally by working with all the RTDD centers, we can keep moving the same way. So that's it from our end, and thanks a lot for this conference. Even though it is in virtual mode, it brought in all possible details and current touch points that we need to look on, and we will connect to individual RTDs from whom we can share some of the technologies and also tap few of them. Thanks a lot.
Thank you, Professor Aishwarya, for those invaluable remarks. I call upon IIT Bombay, members from IIT Bombay to please. Hello?
Dr. Prasenjit, I think they may not be connected. So we invite any other RUTAC centers representatives if present here.
Sure. So I invite members from IIT Kharagpur, Professor Bhadoria, to please address us.
He also doesn't seem to be there.
He's not there. He is not available. Yeah, yeah.
So we'll move ahead. If I can invite members from IIT Kanpur to please address us.
Again, no one.
Okay. If I please invite members from IIT Roorkee, if someone is here.
Respected esteemed guest, is that I'm audible?
Yes, yes, sir.
Respected esteemed guests, all respected delegates and different NGOs, a very good afternoon to all. First of all, I would like to congratulate IIT Jodhpur team for organizing such a wonderful conference. No doubt, this conference was very well conducted. I would really like to congratulate once again to IIT Jodhpur team for conducting this RTD conference. I also thankful to them because they really brought all the developed technologies by different RTs in under one platform. So this was a good event, and they have really enlightened us with their different type of papers, right from app development for smart vending cart to water wheel, water pumping system. So there is wide variety of technologies which were discussed during this conference, and they are really helpful for all the RUTEC centers as well as for different NGOs. I think these presentations were full of knowledge, innovation, and each presentation shows dedication to do something for rural society, and which is common goal of RUTAG. So with this, once again, I would like to congratulate to IIT Jodhpur team for organizing this event. Thank you very much.
Thank you, Professor Saini. We now welcome members from IIT Guwahati to please. Okay, we shall move ahead. If RUTAC members from IIT Indore, they are present. Can I invite members from IIT Ropar if they are present to address us? Okay, so anyways, thank you so much for your remarks. We shall move ahead, and I now invite Professor Vadera, Deputy Director, IIT Jodhpur, and formerly Outstanding Scientist and Director DRDO of the Defense Laboratory Jodhpur, to please deliver the vote of thanks.
Very good afternoon to all. Hope I am audible.
Yes, sir, we can hear you.
Yes, sir, you are.
Yeah. Well, it has been a very nicely organized conference. As I was hearing, remarks from various RUTAC centers. So it has been really a wonderful 2.5 days, very intense churning and deliberations during this third international conference on rural technology development and delivery. And this is conducted by Center for Emerging Technologies for Sustainable Development at IIT Jodhpur. Before going to the formal vote of thanks, I had certain thoughts in my mind. I thought I can, this learned audience, I can share, because though I'm not from the area, in 2016, I got an opportunity to give a talk on sustainable development at Manipal University, Jaipur. Till that time, I was not having any idea that what is sustainable development. And then I was to give a talk, and then I found this term as an intriguing term, in my opinion. Why a development cannot be sustainable, or why a development is non-sustainable? I always thought that development is always sustainable and should help in sustaining better and better. And that just gave me, the few points, just couple of points that, if it is non-sustainable, then due to what? One is it direction of the development, which is not in the right path? And that's why it is non-sustainable. You cannot sustain. Non-sustainable for what? Actually, it is non-sustainable for society, non-sustainable for common men, non-sustainable for, people. So if it is non-sustainable, then is it direction of the development? That's one part. Second was objectives of the development. Are they not rightly placed? Or focus of the development? Or pace of the development? I thought these are some of the points. They are very important to look into if we say that development is not sustainable. Of course, I don't have any idea, but I thought these are also the points wherein one can look at that whether we are moving in the right direction, or our objectives of the development are rightly placed, or our focus of development is rightly placed, or sometimes it is pace of development which also we cannot sustain. So is it that pace of the development which we are not able to sustain? And also when this development happens and this sustainable development term came, it was basically because we were trying to, when we were doing our development, the ecosystem was getting affected badly. Our environment was getting affected badly. And we were thinking that now we'll not be having enough resources to carry on with our development model, which was existing that time. That means we became more vulnerable when we went for the path of development, which we had adopted that time. So can there be any, there must be studies about these things, but can there be any vulnerability analysis when we talk of development? And particularly when we are talking of rural development, we have seen enough of urban development. Now, when we are talking of rural development, can we keep these factors in our mind and see that whatever development we talk, it should be in the right direction, objectively placed, right focus, and also look at the pace of the development so that we are able to manage ourselves with the pace of the development. These were some of the thoughts which I had. And another point which I was thinking is that, there have been really very, very intense discussions, excellent papers, excellent technologies being talked about. Could we have industry also, taking part into this thing? Because we are talking development to delivery, and delivery, whenever we talk, industry's involvement is very, very important. Now I come to the formal part, that is to propose the vote of thanks. And I would like to say that event of this magnitude and also importance cannot be organized without the support that has been given by the Office of PSA and various RUTAC centers which have been associated. And the kind of guidance and support they have provided, I cannot even really think of. I would like to express our gratitude to Dr. R. Chidambaram, who is also chairman of our Board of Governors, for delivering inaugural address. He has been main architect of RUTAG scheme in India. It is he who has actually initiated this scheme in the country. He is always a great source of inspiration, not only for community at IIT Jodhpur, but across the entire country. We are thankful to Professor Shantanu Chaudhary, Director IIT Jodhpur, who has always been guiding the team for this conference, right from the thought process till its inauguration and final culmination. IIT Jodhpur is indebted to advice, encouragement, and support which faculty from different IITs have provided during and before the conduct of RTDD 2022. Specifically, the guidance we got from Professor Subir Saha, Professor Abhijit Deshpande, and Professor Bhadoria. It has been really very important, and it has enabled us to organize the themes and strategy of this conference in a very effective manner. We also thank Springer for accepting to publish the peer-reviewed selected papers as monograph coming out of this conference. We would also thank Professor Vincent Sobojejo from WPI and Professor Dharmendra Saraswat from Purdue University for giving their keynote addresses and sharing their valuable knowledge and years of experience with the entire community. We thank Dr. Ketki Bapat from Office of PSC, Dr. Subir Saha, Dr. Abhijit Deshpande, Dr. Anand B. Rao, IIT Bombay, Dr. PMV Subbarao, IIT Delhi, Dr. B.S. Bhadoria, IIT Kharagpur, and Dr. S.K. Kakoti, IIT Guwahati, for being advisor to the third RTDD 2022 conference and guiding us. A special mention for Professor Rajlakshmi Chauhan. She has been very helpful in helping us and conducting this entire process of virtual streaming, virtual organization of this conference, and without any glitch, without any problem, so smoothly. So grateful thanks to Dr. Rajlakshmi. I thank our staff from Computer Center and other sections of the institute, namely Sunil Purohit, Poonam Chand Sakla, Ramji, Shyam Sundar Sarma, for their help in organizing this event smoothly. Our RUTAG students need special mention, namely Yogesh Sharma, Vishwadeepak, Dakesh Sahu, Keur Kansara, Miraj Ahmed, Pankaj Jakhar, Akanksha, Shubham Pandey, Ajay Kumar, and Chandan Mukherjee for their efforts to make this conference success. Without being students, conference becomes almost nothing. So their efforts is gratefully acknowledged. We thank our project staff colleagues, Bharat Singh Rathod, Nirmal Gehlot, Hanwan Singh, and Chandan Sharma for coordinating day-to-day administrative work related to conference. We also thank our faculty colleagues at Center for Emerging Technologies for Sustainable Development and Computer Center for their active participation and support in organizing this conference. We thank Professor Ravindra, Professor Barun Patihar, Professor Pradeep Tiwari, Professor Shobna Singh, Professor Sumit Kalra, Professor Meenu Chabra, Professor Sudipto Mukhopadhyay, Professor Rajlakshmi Chauhan, and Professor Prasenjit Tribhuvan for chairing various sessions of the conference. Sincere thanks are to Professor Tribhuvan for being master of ceremony or master of the conference for all the 3 days. Finally, big thanks and compliments to Dr. Anand Palapalli and Dr. Sudipto Mukhopadhyay and their team for this wonderful and absorbing conference. I'm sure as an outcome of this conference, we shall have an action plan for the future. We would have wished to have this conference offline at IIT Jodhpur, but because of the circumstances, we have organized this conference virtually. However, All of you are most welcome to visit to IIT Jodhpur. It's a beautiful campus, and you will love to see this campus, and you will love to interact with our people. I wish to mention here that we at IIT Jodhpur are very well committed to the development of rural technologies for the benefit of our country, for the benefit of our rural population. Wish you all great time, and Jai Hind. Thank you.
Thank you, sir, for those words of encouragement. We shall now all rise for the national anthem. Okay, so I thank everyone once again, and I think we can break now. Yes.
Thank you and best
Thank you
wishes to
all.
all. Thank
Let's
you.
give big hand to Anand Palapalli and the team, Sudipta.
It's thank you to actually all the guidance that I have got from all the professors I have interacted, and without which, our team here, especially I am not a main person, but there are a lot of people here need to be thanked, and without their teamwork and other things, we could not have ever pulled up, and the support we received from Professor Chaudhary and Professor Vadera and the administration and others, it has been very other than that, it is really very difficult. The other thing is that I received a lot of lot of thought processes from Professor Saha, Professor Abhijit Deshpande, and Professor Bhadoria came here a couple of months back to streamline everything, and it's amazing to learn a lot from him. I learned on that day how to put this each and every part of this particular how to divide the papers, how to put them together, and without those guidances, and every time I got a lot of advice from Professor Ketki Bapat. It's amazing that we were able to do it just because of all these guidances. Other than that, it's amazing to see all of you. It's a great learning experience, and if there is any mistake from our side, please. Thank you.
There is one mistake, the
Thank you
food.
all.
Yeah, so yes,
Good. Great.
really
Wonderful.
grateful to all of you. Really grateful to all
Yes,
of you for guiding us and helping us to deliver this conference to as best as we can. Of course, we do miss the physical presence and food, and we hope that in the next RTDD we will have all that and more.
Okay.
Thank you, everybody. Thank you once
Okay.
again.
Bye. Bye. Bye.
Thank you. Thank you so much, sir.
Thank you.
Thank you. Bye.